There is something deeply unsettling about the universe that most people never stop to think about. Not the black holes, not the exploding stars, not even the idea that entire galaxies can collide, but the silence. Because out there, beyond Earth's atmosphere, beyond the warmth of sunlight and the comfort of familiar sounds, the universe is almost completely silent. No screaming winds, no roaring fire, no echo of destruction, just endless motion without a voice. And somehow, that makes space feel even more frightening. Right now, as you lie here listening to this, the Milky Way is moving around you at more than 800,000 kilometers per hour. Stars are exploding in distant corners of the galaxy. Giant clouds of gas are collapsing into newborn suns. Invisible radiation races through the darkness. Entire planets drift alone between the stars, and yet, you would hear absolutely nothing. Imagine standing near a star the size of millions of Earths as it violently tears itself apart in a supernova bright enough to outshine an entire galaxy. You wouldn't hear the explosion. Imagine floating near two neutron stars spiraling toward each other, moving faster and faster until they collide with enough force to bend space itself. Still, silence. Even near a black hole, where gravity twists reality into something almost unrecognizable, there is no cosmic roar waiting for you. Only quiet. A quiet so complete that the human mind struggles to truly understand it. On Earth, silence is rare. There is always something humming in the background, wind brushing through trees, distant traffic.
The soft vibration of electricity hidden inside walls. Even in the middle of the night, our world is alive with sound. But space is different. Space does not carry sound the way air does. There is no atmosphere stretching between the stars, no ocean for vibrations to move through. The galaxy is filled with unimaginable violence, but almost none of it can actually be heard. The result is a universe that feels strangely ghost-like, ancient, detached, as though all these colossal events are happening behind a sheet of invisible glass. And perhaps the strangest part of all is that the silence isn't truly empty. Scientists have discovered that the Milky Way is filled with motion hidden beneath the quiet. Invisible magnetic fields ripple through the galaxy like submerged currents beneath a dark ocean.
Clouds of interstellar dust slowly fold and twist through space. Radiation hums silently through enormous voids between stars. Everything is moving. Everything is alive. But none of it speaks in a language our ears can hear. In some regions of the galaxy, stars drift so far apart that the night sky from nearby planets might appear almost empty. Imagine standing on the surface of a frozen rogue planet, a world with no sun, wandering endlessly through interstellar darkness. No sunrise, no sunset, no sound. Above you, perhaps only a few distant stars glow faintly like forgotten candles. And beneath that sky, the silence would feel endless. Not peaceful, not comforting, but ancient. The kind of silence that makes you aware of your own heartbeat. Astronomers sometimes describe deep space as a vacuum, but emotionally, it feels more like a cathedral. Vast, dark, sacred. A place where even the smallest movement seems important. And yet, hidden inside this stillness are events powerful enough to reshape galaxies. Right now, somewhere in the Milky Way, a massive star may be reaching the end of its life. Its core is collapsing inward, while its outer layers prepare to erupt into space. Heavy elements, iron, gold, oxygen, are being forged inside unimaginable heat. The atoms created in that dying star may one day become part of another solar system, another planet, perhaps even another living being staring up at the stars asking the same questions we ask now. And through all of it, the galaxy remains silent. Maybe that is why the universe feels so mysterious to us, because human beings are creatures of sound. We cry, we whisper, we sing, we speak to prove that we are here. But the cosmos does none of those things. It simply moves, quietly, patiently, as though time itself means nothing to it. And perhaps tonight, as you rest beneath this spinning galaxy, that silence becomes a little easier to feel, not as emptiness, but as something deeper, a reminder that the universe does not need noise to be alive. The stars continue burning whether we hear them or not. The galaxy continues turning whether anyone notices or not. And somewhere far beyond the reach of sunlight, beyond the familiar sky of Earth, the quietest places in existence are still waiting, cold and endless beneath the stars. And yet, despite all that silence, space is not empty. That may be one of the greatest illusions ever created by the night sky. When we look upward, the darkness between the stars appears calm and hollow, like a perfect vacuum untouched by movement or life. The stars themselves seem isolated, separated by enormous regions of nothingness. But the truth is far stranger. Between those distant suns lies an invisible ocean, a vast drifting sea of gas, dust, radiation, magnetic fields, and ancient particles slowly moving through the Milky Way in currents so enormous that entire solar systems could disappear inside them unnoticed. Astronomers call it the interstellar medium, but that name almost feels too small for what it truly is. Because this hidden ocean stretches across the galaxy itself. It flows through spiral arms, wraps around dying stars, feeds newborn suns, and quietly shapes the future of everything in the Milky Way. Right now, as Earth moves through space, our solar system is sailing inside this cosmic sea. You cannot see it, you cannot feel it, but it is there. Thin clouds of hydrogen drift across unimaginable distances. Microscopic grains of carbon and silicate dust tumble slowly through the dark. Shock waves from ancient supernovae continue expanding long after the stars themselves have vanished. The galaxy is breathing around us, slowly, silently, endlessly. If you could somehow observe this interstellar ocean over millions of years compressed into seconds, the Milky Way would no longer look calm. It would look alive. Enormous rivers of gas would twist through spiral arms. Vast clouds would collapse inward like storms forming over an alien sea. Magnetic fields would ripple across the darkness like invisible tides. Everything would be moving, not quickly like waves crashing on Earth, but slowly, patiently, like currents deep beneath a black cosmic ocean. Some of these clouds are so large that they span hundreds of light years. Inside them, temperatures can fall so low that atoms barely move. And yet within those freezing regions, gravity quietly begins its work. Tiny fluctuations grow, material gathers, pressure increases, and eventually, somewhere inside the darkness, a new star ignites. That means stars are not born from emptiness. They are born from the drifting remains of older stars. The Milky Way recycles itself endlessly. Dead stars scatter material into space. That material joins the interstellar sea, and from that sea, new stars emerge. In a way, the galaxy behaves less like a machine and more like an ecosystem. A living cycle of death and rebirth unfolding over billions of years. Even our own sun was once part of this ocean. Long before Earth existed, before oceans formed here, before the first living cell ever breathed, the atoms that would become your body drifted silently through interstellar space. Carbon, oxygen, iron, calcium. All of it traveled through the galaxy inside ancient clouds of dust and gas. Some of those atoms may have passed near exploding stars. Others may have crossed through invisible magnetic storms. For millions of years, they wandered the Milky Way unseen, until gravity slowly gathered them together into a new solar system, and eventually, into you. That realization changes the way space feels. The darkness between stars is not empty wilderness. It is a place of transformation, a place where matter waits, where future worlds sleep inside cold clouds, where the ingredients of life drift silently across impossible distances. In certain regions of the galaxy, this interstellar ocean becomes violent. Massive stars unleash stellar winds powerful enough to carve gigantic cavities into surrounding gas. Supernova explosions send shockwaves racing through space at millions of kilometers per hour, compressing clouds and triggering new waves of star formation. The result is turbulence. Immense invisible storms moving through the Milky Way. Not storms of rain or water, but storms of plasma, radiation, and magnetic force. And somehow, even amid all this violence, the galaxy still appears peaceful from Earth. That is the strange beauty of cosmic scale. Events too enormous for the human mind unfold so slowly and so far away that they become serene. Like watching snowfall from a distance while avalanches crash high in the mountains beyond sight. Some astronomers believe our solar system may occasionally pass through denser regions of this interstellar sea. As it travels around the galaxy over hundreds of millions of years, the sun drifts through different environments, some calmer, some richer in gas and dust. These journeys may subtly influence planetary climates, cosmic radiation levels, and even the protective bubble surrounding our solar system known as the heliosphere. Which means the galaxy is not just around us, it interacts with us, quietly, constantly, even now. And perhaps the most haunting thought of all is this: most of the Milky Way remains hidden inside darkness we cannot fully see. The interstellar medium glows faintly in radio waves and infrared light, but human eyes are blind to most of it. Entire rivers of hydrogen drift across the galaxy unnoticed except by sensitive instruments orbiting far above Earth. Invisible structures larger than thousands of solar systems continue moving through the dark at this very moment. Silent currents carrying the memory of ancient stars. Sometimes, when people imagine space, they picture isolation, a cold emptiness separating worlds from one another. But maybe the opposite is true. Maybe the galaxy is connected by this enormous hidden ocean, a slow-moving sea binding stars, planets, dust, and light into one continuous story. And somewhere out there tonight, beyond the reach of human sight, those invisible currents continue flowing beneath the silence, like tides moving through the deepest waters of the cosmos. And within this vast, invisible ocean between the stars, there may be worlds with no sun at all. No sunrise, no warm horizon, no familiar sky glowing with daylight, just darkness, endless darkness stretching in every direction. Astronomers believe there could be billions of these wandering planets drifting through the Milky Way, completely alone. They are called rogue planets, worlds untethered from any star, moving silently through interstellar space like forgotten fragments of broken solar systems. And the strangest part is, some of them may not have always been alone. Many rogue planets were likely born the same way Earth was, inside young star systems surrounded by swirling disks of gas and dust. They may once have orbited warm suns beneath glowing skies. Some may even have had moons, oceans, storms, or atmospheres. But over time, gravity can become cruel. In crowded young solar systems, giant planets pull violently on smaller worlds. Stars pass nearby, orbits destabilize. Invisible gravitational interactions slowly build until one catastrophic moment finally arrives. A planet is thrown outward, past its neighboring worlds, past the frozen outer edges of its system, and eventually beyond the gravity of its own star forever, exiled into the dark. Imagine what that journey would look like. A world slowly watching its sun shrink smaller and smaller in the sky over thousands of years. Daylight fading into permanent twilight, temperatures falling lower with every passing century, until finally, the star disappears entirely, and night becomes eternal. There is something haunting about that idea, because planets feel permanent to us, stable, anchored, but in reality, the galaxy is filled with motion and instability. Entire worlds can be cast away like drifting leaves in a storm far too large for them to resist. Some rogue planets may wander for billions of years without ever passing near another star again, completely isolated, completely silent. If you stood on the surface of one, the sky would barely resemble what we know on Earth. There would be no bright blue atmosphere overhead, no sunlight scattering through clouds. Perhaps only a faint scattering of distant stars would puncture the darkness. The Milky Way itself might stretch across the sky like a frozen river of pale light. Beautiful, but cold beyond imagination. Temperatures on many rogue planets could fall hundreds of degrees below freezing. Oceans would harden into solid ice. Atmospheres might collapse and freeze onto the ground itself. And yet, some scientists believe a few of these worlds might still contain hidden warmth deep beneath their surfaces. Even without a sun, the interiors of planets can remain warm for astonishingly long periods due to radioactive decay and leftover heat from their formation. Beneath thick shells of ice, underground oceans might still exist, trapped in darkness far below the frozen crust. Quiet black seas hidden inside wandering worlds. It sounds almost impossible, but perhaps somewhere out there tonight, a lonely rogue planet drifts through the galaxy, carrying an unseen ocean beneath its icy skin. No sunlight has touched it for millions of years. No life from Earth has ever seen it. And still, beneath the frozen surface, liquid water may move silently through the dark. The universe often hides its strangest possibilities in places we least expect. Some rogue planets may be even larger than Jupiter, carrying enough internal heat to glow faintly in infrared light. Others could be small rocky worlds no larger than Earth itself, nearly impossible to detect against the darkness of space. Because that is another unsettling truth. We do not truly know how many rogue planets exist. Most are nearly invisible. They emit little or no light. Astronomers sometimes detect them only when they briefly pass in front of distant stars, bending starlight through gravity like invisible lenses drifting through the galaxy. For every rogue planet we discover, countless more may remain hidden. Unseen worlds crossing the Milky Way in silence. And perhaps the most emotional part of all this is realizing how fragile a home really is in the universe. Earth feels safe because the sun has remained stable for billions of years. Its warmth sustains oceans, weather, forests, and life itself. But rogue planets remind us that not every world is so fortunate. Some planets lose their stars. Some never had one at all. They simply wander, alone among the stars. There is a strange sadness in imagining a planet without a sunrise, a world where darkness has lasted longer than human civilization itself. And yet there is also beauty in it, because even these abandoned worlds remain part of the galaxy's story. They drift through the same interstellar ocean we explored earlier. They pass through invisible magnetic fields and ancient clouds of dust. Gravity still guides them through the Milky Way's enormous structure. Even alone, they belong to something larger. Maybe that is true for us too. Perhaps nothing in the universe is ever completely isolated. Not stars, not planets, not even people. We are all moving through something vast together, even when the darkness around us feels immense. And tonight, somewhere beyond the reach of every telescope pointed toward the sky, countless unseen planets continue their endless journey through the silent galaxy. Cold travelers beneath eternal night. And if you enjoy these quiet cosmic mysteries that let your mind drift far beyond Earth before sleep, you can subscribe and continue this journey with me through the stars. The Milky Way is filled with rivers no human has ever seen. Not rivers of water, not rivers of light, but rivers of force. Invisible magnetic currents stretch across the galaxy, flowing silently through clouds of dust, between stars, and deep into the dark spaces where almost nothing seems to exist. And somehow, the dust of the cosmos moves to their rhythm. Tiny particles born from dead stars drift through these unseen currents, like leaves floating along an invisible tide. The galaxy appears peaceful from Earth, but hidden beneath that stillness is motion everywhere. Silent motion, ancient motion, a cosmic dance happening in complete darkness. Long before humans understood magnetism, the galaxy was already shaped by it. Every spiral arm of the Milky Way carries weak but enormous magnetic fields woven through space itself. They're difficult to imagine because they don't glow, they don't sparkle, they don't reveal themselves directly. But astronomers know they exist because of the way matter behaves around them. Dust grains align, radiation bends, charged particles curve through space like drifting sparks caught in invisible wind. And over time, scientists began to realize something astonishing. The Milky Way is not only made of stars and gas, it is also threaded together by hidden magnetic architecture, a giant unseen framework stretching across more than 100,000 light-years. The dust between stars may look insignificant, tiny particles of carbon, fragments of silicate, frozen molecules drifting through blackness. But this dust is incredibly important. Without it, stars would form differently. Planets might never emerge. Even life itself could be impossible. These grains are the raw ingredients of future worlds, and magnetism quietly guides their journey. As dust drifts through interstellar space, magnetic fields influence how the particles spin and align. Some rotate unbelievably fast, faster than airplane turbines, faster than hurricanes. Some spin billions of times each second, and as they rotate, they release faint microwave radiation into the galaxy. Tiny whispers of energy hidden in the dark. When radio telescopes observe these regions, they detect the soft glow of spinning dust scattered across the Milky Way. What appears empty to human eyes is actually alive with invisible motion. Inside giant molecular clouds, magnetism becomes even more important. These clouds are stellar nurseries, cold regions where gravity slowly gathers gas and dust together. Without resistance, gravity would collapse these clouds rapidly. Stars would form too quickly. The galaxy might burn through its material in violent bursts. But magnetic fields slow the process. They act almost like invisible tension inside the clouds, holding matter back, stretching it, twisting it, creating turbulence that delays collapse for millions of years. This hidden balance shapes when and where stars are born. Every sun in the sky may owe part of its existence to forces no one can see. Even our own sun likely formed within one of these magnetized clouds billions of years ago. Before Earth existed, before oceans, before life, invisible magnetic rivers were already guiding the dust that would eventually become us. Some of the most dramatic magnetic structures rise far above the galactic disk itself. Enormous filaments of magnetized plasma stretch into the halo like glowing threads. Near the center of the Milky Way, astronomers have discovered giant magnetic structures towering hundreds of light-years into space. These strange formations may be linked to ancient explosions, star formation, or activity surrounding the supermassive black hole at the galactic core. They are difficult to observe. Most emit only faint radio waves. Yet together, they reveal that the center of the galaxy is far more chaotic than it appears. The Milky Way is not a quiet pinwheel drifting peacefully through space. It is electrically alive, dynamic, restless beneath the surface. Cosmic rays also travel along these invisible pathways. These particles move at nearly the speed of light, carrying enormous energy across interstellar space. Many were created in supernova explosions long ago. Others may come from black holes or violent stellar collisions. As they move through the galaxy, magnetic fields bend their paths constantly. Without magnetism, cosmic rays would travel in straight lines, but instead, they wander through tangled, invisible currents like travelers lost in a maze. Some eventually reach Earth. Even now, particles from ancient stellar explosions are passing through your body silently. Tiny messengers from distant regions of the galaxy, remnants of events that happened long before humanity existed. What makes magnetic fields so mysterious is how difficult they are to picture. Gravity feels intuitive, light can be seen, but magnetism in deep space behaves almost like a hidden language, a structure behind the structure, You never truly see it directly, only its influence, only the patterns it leaves behind. Astronomers study polarized starlight to map these hidden currents. As light passes through aligned dust grains, its orientation shifts slightly. By measuring these tiny changes, scientists can trace the shape of galactic magnetic fields. In other words, we map invisible rivers by watching how starlight bends around them. It is one of the quiet miracles of science. Human beings standing on a small planet orbiting an ordinary star have learned to detect structures spread across unimaginable distances without ever touching them. If human eyes could suddenly perceive magnetic fields, the night sky would probably become almost unrecognizable. Darkness would no longer appear empty. Immense glowing currents might arc between nebulae. Invisible streams would wrap around spiral arms. Clouds of dust would shimmer like underwater sand drifting in ocean tides. The entire galaxy might resemble a vast, luminous nervous system pulsing through space. And perhaps for the first time, we would understand that silence does not mean stillness. The cosmos is always moving, always flowing, always shaping itself in ways hidden from ordinary sight. Tonight, while Earth turns quietly beneath the stars, those invisible rivers continue flowing through the Milky Way. Dust still drifts inside ancient magnetic currents. New stars slowly gather inside dark clouds. Charged particles race through interstellar space, and somewhere far beyond human vision, cosmic dust continues its endless dance through fields older than civilization itself. The galaxy is not empty. It is filled with hidden motion, invisible structures, silent forces. And all around us, the rivers we cannot see continue carrying the universe forward through the dark. The gold in the ring you wear may have been created when two neutron stars collided billions of years ago. Not inside Earth, not inside the Sun, but in one of the most violent explosions the universe can produce. Long before human beings existed, somewhere deep in the darkness of the Milky Way, two dead stars may have spiraled toward each other in silence. They were not ordinary stars anymore. They were neutron stars, the collapsed remnants of massive suns that had already exploded long ago. These objects are almost impossible to imagine. A neutron star can contain more mass than the Sun while being only about 20 kilometers across. Matter inside it is compressed so tightly that atoms themselves collapse. A single spoonful would weigh more than a mountain. And yet, despite their terrifying density, some neutron stars do not drift alone. Sometimes two of them become locked together by gravity. For millions of years, they orbit each other in darkness like cosmic dancers circling closer and closer with every turn. At first, the motion is slow, patient, almost peaceful. But gravity never stops pulling. Each orbit drains a tiny amount of energy into space in the form of gravitational waves, ripples that stretch and squeeze the fabric of the universe itself. The stars spiral inward, closer, faster, closer still, until eventually, after ages beyond human comprehension, the final collision arrives. In less than a second, the quiet dance becomes catastrophe. The explosion is called a kilonova, and during that brief moment, temperatures rise to unimaginable extremes. Matter crashes together with such violence that entirely new elements are born. Gold, platinum, uranium. Some of the rarest and heaviest materials in existence are forged in these collisions. For centuries, humanity admired gold without truly knowing where it came from. Ancient civilizations believed it was divine. Others thought it formed deep inside Earth through mysterious geological forces. But the truth appears far stranger. The gold inside jewelry shops, wedding rings, coins, and buried treasure may have originated in exploding neutron star debris scattered across the galaxy billions of years ago. Which means the atoms humans consider precious were born in cosmic destruction far beyond our world. There is something hauntingly beautiful about that. The universe creates its most valuable materials not in calmness, but in violence, not in stability, but in collapse. After the collision, enormous clouds of newly forged matter are blasted outward into space at incredible speeds. Those elements drift through the galaxy for millions of years, mixing with gas and dust inside interstellar clouds. Eventually, gravity gathers those clouds together again. New stars form, new planets emerge, and inside those young worlds, traces of ancient collisions remain hidden in rock, metal, oceans, and eventually living things. Some of the atoms around you tonight may have traveled across the Milky Way since before the sun was born. The iron in your blood, the calcium in your bones, the gold humans wear close to their skin. All of it may carry memories of dead stars. In a strange way, the universe never truly wastes anything. It recycles itself endlessly. Stars die so other stars can form. Explosions scatter ingredients for future worlds. Destruction becomes creation again and again across cosmic time. For a long time, scientists only suspected that neutron star collisions produced heavy elements. The idea sounded almost unbelievable, but in 2017, humanity witnessed proof. Astronomers detected gravitational waves from two neutron stars merging over 100 million light-years away. Almost simultaneously, telescopes across Earth observed the flash of light from the explosion. For the first time in history, humans directly observed the birth of heavy elements happening in real time. It was one of the greatest moments in modern astronomy, not only because it confirmed a theory, but because it revealed something deeply personal. The universe we live in is connected in ways most people never realize. Events happening hundreds of millions of light-years away helped shape the matter beneath our feet. Every precious metal on Earth may carry a story older than our planet itself. Some stars in the Milky Way still preserve evidence of these ancient collisions. Astronomers can study starlight and determine what elements exist inside distant suns. Certain stars contain unusual amounts of heavy materials, fingerprints left behind by neutron star mergers long ago. These stars are like ancient archives, silent witnesses to catastrophic events from the distant past. The galaxy remembers everything through chemistry. Every atom carries history. Even now, somewhere far beyond human sight, neutron stars may be spiraling toward collision again. Entire cosmic dramas unfold constantly in the darkness, without anyone witnessing them. No sound echoes through space, no warning reaches Earth, only silent motion continues. Somewhere in another galaxy, two collapsed stars may already be nearing their final moment, their orbit tightening second by second, space itself trembling softly around them. And when they finally collide, new heavy elements will scatter outward once more. Perhaps future stars will form from those ashes. Perhaps future planets will inherit those atoms. Perhaps one day, billions of years from now, another civilization will hold gold created in that explosion without ever knowing its origin. There is something deeply humbling about realizing that human life is tied to events so ancient and immense. We often think of ourselves as separate from the cosmos, as if Earth were isolated from the rest of existence. But that is not true. Your body is connected to stellar explosions, to collapsing suns, to collisions powerful enough to warp space-time itself. The universe is inside you, quite literally. Tonight, while you rest beneath the quiet glow of the night sky, the galaxy continues its endless cycle of transformation. Stars are dying somewhere. New stars are forming elsewhere. Heavy elements drift through dark interstellar clouds. And hidden within all that motion is the long story of matter itself. A story stretching across billions of years. A story that eventually became planets, oceans, living creatures, and human hands capable of holding starlight in the form of gold. The cosmos is not distant from us. We are one small continuation of its ancient unfolding. Somewhere deep inside the Milky Way, hidden behind enormous clouds of dust and ancient gas, there may be a second structure buried within the first. A galaxy inside a galaxy. Not another universe, not another dimension, but a smaller, hidden bar of stars rotating quietly inside the great stellar bar at the center of the Milky Way. And the strange thing is, we still cannot see it clearly. Even now, after centuries of astronomy, humanity has never truly looked directly into the heart of its own galaxy. The center of the Milky Way remains partially veiled, wrapped in dense curtains of interstellar dust that block visible light from reaching us. When we gaze toward the constellation Sagittarius at night, we are looking toward the crowded core of our galaxy. Yet much of what exists there is still concealed. Infrared telescopes can penetrate some of that dust. Radio waves can travel through it. X-rays reveal violent activity hidden inside the darkness. But even with all of our technology, the galactic center still feels less like a place we understand and more like a distant city glimpsed through heavy fog. And within that fog, astronomers have discovered hints of something unexpected: a second hidden structure. The Milky Way already contains a gigantic central bar, an elongated bridge of stars stretching across the core of the galaxy. This stellar bar helps channel gas inward toward the galactic center, shaping star formation and influencing the motions of billions of stars. But some observations suggest there may be another, smaller bar nested inside it, tilted differently, rotating separately, quietly moving within the larger structure like hidden gears inside an ancient cosmic machine. The idea sounds almost impossible at first. A galaxy is already unimaginably vast, yet within its crowded center, stars may organize themselves into layered structures, each with its own rhythm and motion. Astronomers did not discover this hidden possibility by directly seeing it. Instead, they noticed subtle patterns in the movement of stars and gas clouds near the galactic core. Certain regions appeared to orbit differently than expected. Streams of gas curved in unusual ways. The motions did not fully match the shape of the visible bar alone. Something else seemed to be influencing the flow, something hidden deeper inside. This is one of the strangest things about astronomy. Often, the most important discoveries begin not with what we see, but with what refuses to behave normally. Tiny irregularities become clues. Slight distortions become fingerprints. Invisible structures announce themselves only through gravity and motion. In the Milky Way, gravity writes secrets into the paths of stars. And somewhere near the center, those paths suggest a layered labyrinth of light. If the inner bar truly exists, it may play a major role in feeding material toward the supermassive black hole Sagittarius A star, the enormous gravitational giant resting at the galaxy's core. Gas drifting through the galaxy may gradually funnel inward along these stellar structures, spiraling closer and closer to the center over millions of years. The galaxy may not simply spin, it may circulate, flowing inward through invisible channels like water moving through hidden rivers beneath a city. And yet, almost none of this can be seen directly with human eyes. If you could somehow travel above the Milky Way and look down upon it from intergalactic space, you might see enormous spiral arms curving outward through darkness. You would see glowing clusters of stars scattered like islands across a luminous sea. You would see dust lanes stretching through the disk like shadows painted across light. But near the center, the structure would grow more crowded, more chaotic, more difficult to untangle. The stars there are packed tightly together. Ancient suns orbit in dense swarms. Clouds of hot gas collide and churn. Magnetic fields twist through space. Radiation floods outward from violent stellar remnants, and somewhere within that crowded brilliance, the hidden bar may quietly rotate, unnoticed by almost everyone alive on Earth. There is something strangely humbling about this. Human civilization has mapped continents, crossed oceans, walked on the moon, and sent robotic explorers beyond the edge of the solar system. Yet we still cannot fully describe the shape of the place we live inside. It is as though we were born deep within a forest so enormous that no one has ever seen the entire landscape at once. We know pieces, we infer patterns, but the full architecture remains incomplete. The center of the Milky Way is also a place where time feels different. Stars orbit the core far more rapidly there than in our quiet region of the galaxy. Giant molecular clouds drift through crowded stellar neighborhoods. Explosions from dying stars ripple through the interstellar medium. Entire generations of stars are born and destroyed, while our own sun continues its calm orbit far away in the outer disk. Our solar system circles the galactic center at a distance of roughly 27,000 light-years. We are not near the center at all. We live in a relatively peaceful suburb of the galaxy, tucked quietly inside one of its spiral arms. And perhaps that distance protects us, because the galactic core is not calm. It is alive with motion. Infrared observations reveal immense glowing clouds hidden inside the dust. Radio telescopes detect streams of energetic particles moving through magnetic fields. X-ray observatories uncover violent remnants of collapsed stars and black holes feeding on nearby matter. The deeper astronomers look, the stranger the region becomes. Sometimes, the center of the Milky Way feels less like a stable structure and more like an ecosystem of gravity, light, and invisible forces all competing at once. A shifting maze, a luminous storm, and inside it, perhaps, another hidden layer turning slowly through the dark. What makes this especially haunting is that the hidden bar may have existed for billions of years before humans ever realized it could be there. Long before Earth formed, long before the first oceans appeared, long before life learned to breathe beneath ancient skies, this secret structure may already have been rotating silently inside the galaxy. Entire civilizations have risen and vanished during a fraction of a single galactic rotation. Meanwhile, the Milky Way continues its slow, ancient dance, quietly rearranging itself, quietly evolving, quietly hiding pieces of its own design from the creatures living inside it. And tonight, as you lie beneath the stars, the center of the galaxy is still there beyond the dust clouds. Invisible to your eyes, yet endlessly active. Stars continue circling the hidden core. Gas still flows inward through unseen pathways. The supermassive black hole still waits at the center, like a dark gravitational anchor holding the galaxy together. Far beyond what we can fully imagine, the Milky Way continues building its secret architecture in silence. And somewhere inside that glowing labyrinth of stars, another hidden structure may still be turning slowly in the dark. The Milky Way is not isolated. It is not a sealed island of stars drifting untouched through space. Even now, at this very moment, our galaxy is still feeding. Far beyond the glowing spiral arms we see in photographs, beyond the familiar constellations hanging above Earth, invisible rivers of matter are slowly flowing through the darkness toward the Milky Way. They stretch across intergalactic space in faint, enormous filaments, connecting galaxies together through what astronomers call the cosmic web. The universe is not scattered randomly. On the largest scales, galaxies gather along colossal threads of gas and dark matter woven across billions of light-years. Between them lie vast, empty voids, regions so enormous and lonely that entire galaxies may be separated by unimaginable distances. And along these hidden cosmic highways, matter moves, slowly, silently, continuously. Our galaxy is still drawing material inward from this enormous structure, drinking from reservoirs that were formed not long after the birth of the universe itself. It is strange to think about. When we look at the Milky Way from Earth, it feels ancient and complete, like a finished structure that has existed forever. The stars seem stable. The spiral arms appear calm and permanent. The galaxy feels like a home already fully built. But galaxies are never truly finished. They grow, they consume, they evolve over billions of years like living systems moving through deep time. The Milky Way has spent much of its existence gathering material from its surroundings. Some of that matter arrives through collisions with smaller galaxies. Some falls inward as enormous clouds of gas drifting through the galactic halo. and some may flow directly from the cosmic web itself, traveling across intergalactic darkness before finally reaching our galaxy. Without this constant supply of fresh material, star formation inside the Milky Way would eventually slow down and fade. Stars consume hydrogen as fuel. Over time, galaxies gradually exhaust the gas needed to create new generations of suns. But the Milky Way continues forming stars because fresh matter still arrives from beyond its visible boundaries. In a sense, the galaxy survives by feeding. Some of these inflows are cold and quiet. Thin streams of hydrogen gas slip gently into the galactic disk almost invisibly, blending with existing clouds already drifting between the stars. Other inflows arrive hotter and more violent, crashing inward at enormous speeds and heating up as they collide with surrounding gas. Astronomers detect some of these flows using ultraviolet light. Others appear in X-ray observations. Many remain difficult to trace clearly because they are incredibly diffuse, spread thinly across enormous distances. Yet together, they form a hidden circulation system sustaining the galaxy from the outside. It is almost like weather on a cosmic scale, invisible currents drifting through darkness, vast atmospheric rivers feeding an ocean of stars. And the Milky Way floats inside all of it. There is something deeply unsettling about realizing our galaxy is not stationary. Even on the grandest scales, motion never stops. Gas falls inward, stars orbit the center. Dark matter shapes invisible gravitational landscapes. Satellite galaxies drift around us like companions caught in a slow celestial dance. The universe is never truly still. Even silence is moving. The cosmic web itself may be one of the largest structures in existence. Simulations of the universe show galaxies forming along gigantic filaments of matter stretching through space like glowing neural pathways in a colossal cosmic brain. Where these filaments intersect, clusters of galaxies gather. Between them lie enormous voids almost entirely empty. And somewhere inside one of those vast filaments, the Milky Way continues pulling material inward. We rarely think of galaxies as hungry things, but perhaps they are. Not alive in the biological sense, of course, yet still dependent on continuous exchange with their environment. They recycle gas through star formation, stellar explosions, and galactic winds. They absorb smaller companions. They lose matter into surrounding halos and draw new matter back inward again. The galaxy breathes. It exhales energy and gas through supernova explosions. It inhales fresh material from deep space. And this process has likely continued for billions upon billions of years. Some astronomers believe these gas inflows may even influence the shape of the Milky Way itself. Fresh streams of matter can disturb the galactic disk, alter star formation rates, and create subtle ripples across the spiral structure. Invisible material falling inward today may help shape regions of the galaxy that future civilizations will someday call home. In that sense, the Milky Way is still under construction, still changing, still becoming something new. And perhaps that is true for the universe as a whole. Nothing remains fixed forever. Stars are born and die, galaxies merge, black holes grow. Even the largest structures continue evolving slowly across cosmic time. When you look up at the night sky, it is easy to imagine the stars frozen in place. Human lives are simply too short to witness the enormous motions unfolding above us. The galaxy changes on timescales so immense that its transformations feel invisible. But invisibility does not mean stillness. Right now, while Earth turns quietly beneath the night, clouds of intergalactic gas may be drifting toward the Milky Way from unimaginable distances. Somewhere far above the galactic plane, streams of matter are slowly descending through the halo. New stars are already beginning to form from material that may have spent billions of years wandering through intergalactic space before finally arriving here. Some atoms inside future stars may once have floated between galaxies in total darkness. Some atoms inside you may have traveled those same ancient paths. That is one of the strangest truths about the cosmos. The boundaries we imagine are often illusions. Galaxies exchange matter, stars recycle elements. Dust from dying suns becomes the material for future worlds. Everything flows into something else eventually, and the Milky Way itself is part of that endless circulation. Far beyond the visible stars, beyond the glowing core and spiral arms, beyond even the faint halo surrounding the galaxy, the universe stretches outward into deep black distances threaded by invisible structures older than Earth itself. Along those silent threads, matter continues moving, slowly feeding the galaxy, slowly sustaining the stars, slowly shaping the future of the Milky Way while we sleep beneath its light. And tonight, somewhere in the darkness between galaxies, another unseen river of cosmic matter may already be falling toward us from the edge of the ancient universe. Somewhere above the glowing disk of the Milky Way, enormous towers of hot gas are rising into darkness. They are not mountains, not clouds, not anything built by intelligence. They are gigantic galactic chimneys, structures so vast that they stretch for thousands of light years above the plane of the galaxy, carrying energy and matter upward into the halo like smoke escaping from an invisible fire. And the strange thing is, these colossal structures are born from death. Deep inside the spiral arms of the Milky Way, stars are constantly forming within cold molecular clouds. Most live quietly for millions or billions of years, but the largest stars burn fast and violently. They consume their fuel with astonishing speed, shining with immense brightness before reaching catastrophic endings. When these massive stars die, they explode as supernovae. For a brief moment, a single dying star can outshine entire galaxies. The explosion sends shock waves racing outward through the interstellar medium, heating surrounding gas to enormous temperatures. Nearby clouds are compressed, magnetic fields twist violently, radiation floods into space. And if many massive stars are born together in the same stellar region, their deaths can overlap. One explosion after another, a chain reaction of cosmic violence. Over time, these repeated supernova blasts carve enormous cavities into the galaxy itself. Astronomers call these regions superbubbles. Inside them, gas becomes incredibly hot and thin, reaching temperatures of millions of degrees. The pressure continues building as more stars explode, and eventually, the superbubble can rupture upward through the galactic disk. When that happens, the galaxy opens. A tunnel forms, a chimney stretching from the dense stellar plane into the surrounding halo. Hot gas surges upward through these structures, carrying energy, particles, and heavy elements far above the visible galaxy. It is strange to imagine the Milky Way this way, not as a silent, flat spiral floating peacefully through space, but as something dynamic and breathing, a system constantly venting material outward and drawing matter back inward again. The galaxy exhales. These galactic chimneys are part of that breath. Some extend for thousands of light years. Entire columns of hot plasma rise through them into the halo surrounding the Milky Way. Magnetic fields travel along these outflows. Cosmic rays stream outward at enormous speeds. Gas enriched by generations of dead stars escapes the crowded disk and spreads into the larger galactic environment. Without these structures, the Milky Way would behave very differently. The pressure inside the galactic disk would continue building. Star formation might become unstable. Heavy elements forged inside stars would remain trapped near their birthplaces instead of being redistributed across the galaxy. In a sense, these chimneys help regulate the life cycle of the Milky Way itself. And yet they remain almost entirely invisible to human eyes. We cannot look into the night sky and see them directly. Most reveal themselves only through radio waves, X-rays, or ultraviolet observations. Astronomers detect their presence through temperature maps, energetic emissions, and the strange motions of gas moving far above the galactic plane. Some of the largest structures ever discovered near the center of the Milky Way may be related to this same process. In 2010, scientists studying gamma rays discovered two enormous lobes extending above and below the galactic core. These structures, now known as the Fermi bubbles, stretch for roughly 25,000 light-years in each direction. No one knows exactly how they formed, but they may be linked to ancient outbursts from the supermassive black hole at the galaxy's center, or from intense periods of star formation long ago. Whatever created them released unimaginable amounts of energy. The Milky Way may carry scars from ancient eruptions far more violent than anything humanity has ever witnessed. And perhaps smaller galactic chimneys scattered across the disk are echoes of the same fundamental process. Energy seeking escape, pressure searching for release, the galaxy trying to balance itself across enormous spans of time. There is something hauntingly beautiful about this idea. Stars are born from collapsing clouds of gas. They shine for millions of years. Then, some die violently enough to punch tunnels through the galaxy itself. The material they release rises into the halo, cools slowly, and may eventually drift back down into the disk to form future stars. Nothing is wasted. Even destruction becomes part of creation. The iron in planets, the oxygen in atmospheres, the calcium in bones. Much of it was scattered long ago by exploding stars and carried through the galaxy by invisible flows like these. In that sense, galactic chimneys are not merely strange astronomical structures, they are pathways of recycling. They move the ashes of dead stars into the wider cosmos so that future worlds can someday form from them. And perhaps somewhere else in the Milky Way tonight, another civilization is looking upward beneath its own dark sky, unaware that ancient stellar debris helped create the atoms within them too. The galaxy connects everything through motion. Gas rises, gas falls, stars die, stars are born again. The Milky Way is not static. It circulates endlessly, like a vast ecosystem operating on scales too large for human intuition to fully grasp. Even silence participates in that circulation. Far above the spiral arms, the halo of the galaxy glows faintly with hot gas expelled long ago. Some of it may drift there for millions of years before cooling and slowly raining back down toward the disk in what astronomers call the galactic fountain. A quiet cycle, matter rising and falling across cosmic time, breathing through colossal invisible chimneys in the dark. And perhaps the most extraordinary part is this. All of it is happening right now. While cities sleep beneath Earth's atmosphere, somewhere in the Milky Way, a massive star may already be nearing collapse. Somewhere else, shock waves from ancient explosions are still expanding through interstellar clouds. Hot gas is still rising upward through hidden tunnels stretching thousands of light years into space. The galaxy is alive with processes we rarely notice. Ancient forces still shaping the structure around us. And far above the glowing disk of the Milky Way, invisible towers of stellar fire continue carrying the breath of dead stars into the endless dark. If you'd like, leave a comment and let me know if you want a full future episode exploring the strangest structures ever discovered inside the Milky Way. If human eyes could see X-rays, the night sky would become almost unrecognizable. The calm silver band of the Milky Way stretching quietly across the darkness would vanish. In its place, we would see a galaxy alive with violent flashes, scorching clouds of plasma, collapsed stars feeding on stolen matter, and invisible storms of radiation tearing through space. The galaxy would no longer look peaceful. It would look like fire. To our eyes, the Milky Way appears soft and tranquil. Stars glow gently. Dust clouds drift like shadows across a river of light. The night sky feels silent and still, almost comforting in its distance. But visible light tells only a tiny fraction of the story. Beyond the narrow range our eyes evolved to detect lies a hidden universe of energy. Radio waves reveal cold hydrogen drifting through space. Infrared light exposes stars hidden behind dust. Gamma rays uncover violent particle collisions. And X-rays show some of the most extreme environments in existence. In X-ray light, the Milky Way becomes a completely different place. Not a quiet spiral galaxy, but a restless machine of heat and gravity. Much of this hidden radiation comes from objects born through death. When massive stars exhaust their fuel, they collapse under their own gravity. Some explode as supernovae and leave behind neutron stars, tiny stellar remnants so dense that a teaspoon of their material would outweigh mountains on Earth. Others collapse further into black holes, regions where gravity becomes so intense that even light cannot escape. These remnants continue shaping the galaxy long after the original stars are gone, and many of them shine fiercely in X-rays. A black hole by itself emits no light, but when gas falls toward one, the material spirals inward into an accretion disk, heating to millions of degrees through friction and gravity. Before disappearing forever beyond the event horizon, that gas can release enormous amounts of energy. In X-ray images, these regions blaze like cosmic furnaces. Neutron stars do something similar. Some exist in binary systems, orbiting companion stars closely enough to pull material away from them. Gas stolen from the companion crashes onto the neutron star's surface at incredible speeds, heating up until it glows intensely in X-rays. Across the Milky Way, these hidden systems flicker and flare continuously. Tiny points of unimaginable violence scattered throughout the darkness. And yet we never notice them with our naked eyes. There is something strangely haunting about that idea. The sky above us appears calm not because the universe is calm, but because human senses are limited. Our eyes evolved beneath Earth's atmosphere to detect the wavelengths most useful for survival here on the surface of a planet. We were never meant to see the full energy of the cosmos. If we could, the galaxy might terrify us. The center of the Milky Way would be especially overwhelming. Near the galactic core, stars are packed densely together. Supernova remnants expand through crowded regions of gas. Powerful magnetic fields twist through space. High-energy particles accelerate to astonishing speeds. And at the center itself lies Sagittarius A star, the supermassive black hole containing millions of times the Sun's mass. Although relatively quiet today compared to actively feeding black holes in other galaxies, Sagittarius A star still emits bursts of X-rays and radiation. Astronomers believe it was likely far more active in the distant past, perhaps unleashing eruptions powerful enough to shape huge structures extending above and below the galactic plane. The calm galaxy we see now may simply be the quieter phase of a much more turbulent history. Even the space between stars glows faintly in X-rays. Hot gas fills parts of the galactic halo at temperatures of millions of degrees. Shock waves from ancient stellar explosions continue heating surrounding material long after the explosions themselves have faded. Invisible plasma drifts through the galaxy, carrying traces of ancient violence across enormous distances. In visible light, space often looks empty. In X-rays, emptiness burns. Some of the most important discoveries about the Milky Way have come from X-ray observatories orbiting above Earth's atmosphere. Telescopes like Chandra and XMM Newton can detect high-energy radiation that our atmosphere thankfully blocks from reaching the surface. Without that protection, life on Earth would struggle to survive. The universe is beautiful, partly because we experience only a softened version of it. Above the atmosphere, however, the true high-energy galaxy becomes visible. Astronomers have discovered enormous bubbles of hot gas near the galactic center. They have mapped the remains of exploded stars. They have observed neutron stars spinning rapidly like cosmic lighthouses. They have watched black holes feeding in silence while invisible radiation floods outward into space. The more we study the X-ray universe, the more alive the Milky Way appears. Not alive biologically, of course, but alive dynamically, alive through motion, alive through transformation. The galaxy constantly recycles itself through violence and creation. Stars form from cold clouds of gas. They shine for millions of years. Some die peacefully, others explode catastrophically, scattering heavy elements outward and leaving behind collapsed remnants that continue radiating energy for ages afterward. Death in the universe is rarely an ending. Usually, it is a transition. The calcium in bones, the iron in blood, the oxygen in lungs, all were forged inside ancient stars long before Earth existed. Some of those stars may have ended as supernovae, powerful enough to briefly outshine entire galaxies. Their explosions shaped the Milky Way we live inside now. And even tonight, while Earth turns quietly beneath the darkness, the galaxy remains full of invisible high-energy activity. Somewhere, a neutron star is pulling gas from its companion. Somewhere, a black hole is consuming matter in silence. Somewhere, ancient hot plasma still drifts outward from explosions that happened before human civilization began, all of it hidden from ordinary sight. Sometimes, that is what makes astronomy feel so surreal. The universe we experience is not the universe as it truly is. It is only the small fraction our senses allow us to perceive. Beyond that narrow window lies another cosmos entirely, a cosmos of radiation, of invisible storms, of collapsed stars glowing like embers in the dark. And if your eyes could somehow see X-rays tonight, the Milky Way above you would no longer resemble a peaceful river of stars. It would look like a colossal living storm of heat and energy stretching endlessly across the night. Some stars in the Milky Way are no longer truly alive, and yet they continue spinning with impossible precision, sending signals across the darkness like ancient cosmic lighthouses. Far beyond Earth, deep within the silent regions between the stars, there are objects so strange that they almost feel artificial. They are smaller than cities, heavier than suns, and capable of rotating hundreds of times every single second. These are pulsars, and even though they were born from death, they have become some of the most reliable clocks in the entire universe. When a massive star reaches the end of its life, gravity finally wins the battle that fusion held back for millions of years. The star collapses inward violently. Its outer layers explode into space in a supernova, while the core compresses so intensely that protons and electrons are crushed together into neutrons. What remains is a neutron star, a sphere only around 20 kilometers wide. Yet inside that tiny object exists more mass than our sun. Matter there becomes unimaginably dense. A single teaspoon of neutron star material would weigh billions of tons on Earth. The atoms themselves no longer behave normally. Space, gravity, and magnetic fields twist into extreme forms. And sometimes, the collapsing star begins to spin faster and faster, much faster. Imagine an ice skater pulling their arms inward during a spin. As their body becomes more compact, their rotation speeds up. The same thing happens when a star collapses. A star once millions of kilometers wide suddenly compresses into something the size of a city. Its rotation becomes violent. Some neutron stars spin once every few seconds. Others rotate dozens of times each second. And the fastest known pulsars can spin over 700 times every second. Faster than the blades of a helicopter. Faster than almost anything humans have ever built. Yet, despite those impossible speeds, they remain astonishingly stable. As these neutron stars rotate, beams of radiation stream outward from their magnetic poles. These beams are not always aligned with the star's rotation axis, which means the light sweeps through space like a lighthouse beam crossing a dark ocean. If Earth happens to lie in the path of that beam, astronomers detect regular pulses of radiation. Pulse, 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 again and again with extraordinary precision. That is why they are called pulsars. For a long time, scientists were stunned by how perfectly regular these signals were. In fact, when pulsars were first discovered in 1967, some researchers briefly wondered if they might be artificial transmissions from intelligent life. The signals were too exact, too rhythmic, too precise. One early pulsar was even jokingly labeled LGM-1, short for Little Green Men. But the truth turned out to be even more fascinating. The universe itself had created natural clocks more accurate than many human inventions. Some pulsars lose less than a second over millions of years. Think about that for a moment. Entire civilizations could rise and disappear while these dead stars continue ticking steadily in the darkness. Silent, invisible, unwavering. Astronomers now use pulsars for some of the most advanced measurements in science. By studying tiny changes in their timing, researchers can measure distances across the galaxy, study the behavior of gravity, and even search for gravitational waves rippling through space-time itself. In a way, pulsars allow us to listen to the structure of the universe, not through sound, but through rhythm. Some pulsars exist alone, drifting quietly through space after the explosion that created them. Others remain locked in binary systems, orbiting companion stars while pulling matter away from them. Gas spirals onto the pulsar's surface, increasing its rotation speed even further until it becomes what astronomers call a millisecond pulsar. These are among the fastest rotating objects known to exist, and still they continue ticking, steady, patient, ancient. The magnetic fields surrounding pulsars are also unimaginably powerful. A normal refrigerator magnet is harmless in your hand, but a pulsar's magnetic field can be trillions of times stronger than Earth's. If one passed too close to our planet, it could disrupt electronics, distort atoms, and damage living tissue instantly. Fortunately, the nearest pulsars remain safely distant, hidden among the stars like dangerous relics of stellar death. Yet, despite their violence, there is something strangely peaceful about them. Perhaps it is the regularity, the predictability, the sense that even after catastrophe, the universe still finds order. A massive star dies in an explosion bright enough to outshine galaxies, and from that destruction emerges a perfectly timed cosmic heartbeat. Some pulsars drift through nebulae illuminated by the remnants of their own explosions. Others move rapidly across the galaxy like runaway bullets, carrying the momentum of ancient supernovas. A few are surrounded by ghostly rings of energized particles glowing faintly in X-rays, but most remain hidden from human eyes. You would never see them looking up at the night sky. Their signals travel mostly through radio waves, invisible to us without giant telescopes listening carefully to the cosmos. And still, every second, countless pulsars continue their endless rotations throughout the Milky Way, like hidden metronomes scattered through the spiral arms, like forgotten clocks keeping time for the galaxy itself. Perhaps that is one of the strangest truths about the universe. Even in places shaped by collapse, violence, and unimaginable gravity, rhythm survives, order survives, light survives. Tonight, somewhere beyond the stars above your roof, a pulsar is spinning silently in the dark. Its beam sweeps across empty space again and again. Maybe it has been doing so since before human civilization began. Maybe it will continue long after humanity is gone. A dead star, still ticking, still turning, still whispering through the galaxy with mechanical precision no human hand could ever truly recreate. And while you rest here on Earth, beneath the calm sky of a quiet world, those distant cosmic clocks continue counting the ages of the universe, one pulse at a time. The galaxy is speaking right now, not in words, not in sounds your ears could ever hear, but across the darkness of space, invisible waves are constantly traveling between the stars, like whispers moving through an endless night. If human eyes could see radio waves, the Milky Way would no longer appear calm and silent. The sky would flicker with hidden storms, glowing clouds, spinning pulsars, and streams of energy stretching across unimaginable distances. The universe is not quiet. We are simply listening with the wrong senses. For most of human history, the night sky looked peaceful. Ancient people gazed upward and saw fixed stars, soft moonlight, and a dark emptiness beyond. Even after telescopes revealed galaxies and nebulae, we still believed space was mostly silent and still. But in the 20th century, humanity discovered something extraordinary. The cosmos was filled with invisible signals. Radio waves are a form of light, just like visible light, infrared, or X-rays. The difference is that radio waves have much longer wavelengths. Human eyes cannot detect them naturally, but radio telescopes can. And once astronomers began listening to the sky through radio astronomy, the universe transformed completely. Suddenly, space was alive with motion. Cold hydrogen gas drifting through spiral arms emitted faint radio signals. Pulsars pulsed like distant beacons. Black holes surrounded by spinning disks of matter screamed with jets of radiation. Entire galaxies whispered across millions of light years. Even the empty regions between stars were not truly empty. They shimmered with hidden activity. One of the most important discoveries made through radio waves was the structure of the Milky Way itself. Because dust clouds block visible light, humans cannot directly see across the galaxy's full disk using ordinary telescopes. But radio waves can pass through dust. They travel through the darkness almost untouched. Using giant radio dishes spread across deserts and mountains, astronomers slowly mapped the spiral arms of our galaxy. They traced enormous rivers of hydrogen gas curving through the Milky Way like glowing veins. Without radio astronomy, humanity would still struggle to understand the true shape of the galaxy we live inside. In a strange way, we learned what our home looked like by listening instead of looking. Some of the most haunting radio signals come from pulsars. These collapsed stars rotate with astonishing precision, sweeping beams of radiation through space like cosmic lighthouses. Each pulse arrives with incredible regularity. Tick, tick, tick. The signals are so precise they almost feel artificial. If converted into sound, some pulsars resemble mechanical heartbeats echoing through darkness. Others produce rapid, clicking rhythms like rain tapping against glass. These are the remains of dead stars, still speaking long after their destruction. Radio telescopes have also revealed enormous clouds of cold gas floating silently between the stars. Some of these clouds span hundreds of light years and contain the raw material for future solar systems. Inside them, gravity slowly gathers matter together until new stars ignite. Long before a star becomes visible, radio waves can reveal its hidden birthplace. This means radio astronomy allows humanity to witness the earliest stages of stellar creation, peering into cocoons of dust that visible light cannot penetrate. It is like hearing life before seeing it. And beyond our galaxy, radio waves travel from even stranger objects: quasars. These distant galactic cores are powered by supermassive black holes consuming matter with unimaginable violence. As gas spirals inward, enormous jets erupt outward at nearly the speed of light, blasting radiation across intergalactic space. Some quasars shine brighter than entire galaxies. Yet from Earth, many appear only as tiny points. Without radio telescopes, we would never fully understand their immense power. The universe hides its loudest phenomena behind invisibility. Even our own planet constantly receives radio whispers from space. Every second, waves pass through your body unnoticed. Signals from distant stars, remnants of ancient explosions, and radiation older than Earth itself drift silently through the room around you. One of these signals is the cosmic microwave background, the faint afterglow of the Big Bang. It has been traveling across the universe for over 13 billion years. Right now, traces of the universe's birth are moving through the air surrounding you. Invisible, ancient, endless. There is something deeply beautiful about that thought. The galaxy is not merely an object we observe from afar. It is an ocean of information constantly flowing around us. Humanity has simply learned how to translate a small portion of its language. Massive radio observatories now scan the heavens day and night. Some consist of giant single dishes stretching hundreds of meters wide. Others are arrays of smaller antennas working together across entire continents. Together, they form ears large enough to listen to the cosmos. And the more carefully we listen, the stranger the universe becomes. astronomers have detected mysterious fast radio bursts, brief flashes of energy so powerful they can release more energy in milliseconds than the sun emits in days. Some repeat, others appear only once and vanish forever. Their exact origins remain uncertain. Some may come from highly magnetic neutron stars called magnetars. Others may arise from processes not yet fully understood. For a moment, the galaxy shouts. Then silence returns. There are also sounds hidden within planets and stars themselves. Scientists can convert electromagnetic signals into audible frequencies, allowing us to hear the vibrations of Saturn, the oscillations of the Sun, or the eerie plasma waves near distant worlds. These sounds are not carried through air like normal sound on Earth. Space is far too empty for that. Instead, they are translations, the hidden music of physics transformed into something human ears can finally experience. And when you listen to them, they often sound strangely haunting, like the universe dreaming in its sleep. Perhaps that is why radio astronomy feels so different from ordinary observation. Looking at the stars makes us spectators. Listening to them makes us participants. It creates the feeling that the galaxy is not dead or distant, but active and alive, humming quietly beyond human senses. Tonight, while cities glow beneath artificial lights and most people sleep unaware, radio waves continue crossing the Milky Way in every direction. Signals from pulsars, clouds of hydrogen, distant black holes, ancient remnants of the Big Bang, an endless, invisible conversation unfolding across the dark. And somewhere beneath that vast cosmic chorus, our tiny planet drifts quietly through the spiral arms, listening carefully to a universe that has been speaking all along. The sun was not born alone. Long before Earth existed, before oceans formed, before the moon circled our sky, before the first living cell emerged on this planet, the sun may have shared its birthplace with thousands of other stars. Somewhere in the Milky Way, hidden among billions of lights, the lost siblings of our sun may still exist, scattered, drifting, forgotten by time. When we look at the sun today, it feels solitary. It hangs alone in space, surrounded only by planets, asteroids, comets, and distant darkness. But stars rarely form in isolation. Across the galaxy, stars are usually born together inside enormous molecular clouds, cold regions filled with gas and dust stretching across light years. Gravity slowly gathers the material inward. Dense knots begin collapsing. Over time, hundreds or even thousands of newborn stars ignite within the same stellar nursery. The process is chaotic and beautiful. Young stars shine through glowing clouds, while stellar winds carve tunnels through the dust. Radiation floods outward. Shock waves ripple across space. And somewhere inside one of these ancient nurseries, around 4.6 billion years ago, our sun opened its eyes for the first time. It likely formed beside countless neighboring stars. Some may have been larger and brighter, others smaller and dimmer. For a brief period in cosmic history, the sun belonged to a crowded family. The night sky from early Earth did not yet exist, but if it had, it might have looked very different from the quiet darkness we know today. Nearby stars may have glowed brilliantly across the newborn solar system, hanging close together like lanterns in a celestial city. But star clusters do not last forever. Over millions of years, gravity slowly tears them apart. As stars orbit the center of the galaxy, they encounter giant molecular clouds, spiral arms, and passing stars. These interactions gradually scatter the cluster members in different directions. Like leaves drifting away in a river, the siblings separate. Some move inward toward the galactic core. Others drift outward into the halo. Many become impossible to trace. Eventually, the cluster dissolves completely. The family disappears. And that is likely what happened to the sun's birth cluster. Its siblings wandered away long ago, swallowed by the immense scale of the Milky Way. Yet astronomers believe some of them may still exist. Somewhere out there, distant stars may share the sun's age, motion, and chemical fingerprint because they were born from the same cloud of gas. Finding them is incredibly difficult. After billions of years, stars travel enormous distances around the galaxy. The Sun itself has already completed many orbits around the Milky Way since its birth. Its siblings have done the same, each following different paths through the spiral arms. The cluster became scattered across thousands of light years. Still, scientists continue searching. Modern missions like the European Space Agency Gaia spacecraft are helping astronomers map the positions and motions of billions of stars with extraordinary precision. By studying stellar chemistry and trajectories, researchers hope to identify stars that may once have formed beside our Sun. It is almost like cosmic genealogy, a search for ancient relatives lost across the galaxy. Some candidate stars have already been proposed. They share unusual similarities with the Sun in age and composition, hinting at a possible shared origin. But certainty remains elusive. The Milky Way is vast, and memories fade even among stars. There is something strangely emotional about this idea. The Sun, which feels eternal and isolated from our perspective, may actually be one surviving member of a long-dispersed stellar family. Its siblings could now orbit in completely different regions of the galaxy, unaware of one another in the silent language of gravity. Perhaps one shines near the galactic center. Another may drift high above the disk. Some may already be dead, having burned through their fuel billions of years ago. Massive stars live quickly and die young. If the Sun had large siblings, they may have exploded as supernovas long before Earth even formed completely. And strangely enough, those ancient explosions may have helped shape our own existence. Scientists suspect that a nearby supernova may have enriched the young solar system with heavy elements shortly after the Sun formed. Certain radioactive isotopes found in ancient meteorites hint that material from an exploding star reached the cloud that eventually became Earth and the planets. In a sense, the Sun's siblings may have influenced the birth of our world. The iron in your blood, the calcium in your bones, the gold carried through human history. All of it traces back to ancient stars that lived and died long before humanity appeared. The Sun did not emerge into emptiness. It emerged into inheritance. Even today, the Milky Way continues producing stellar families inside giant nebulae. Regions like the Orion Nebula glow with newborn stars wrapped in clouds of dust and gas. These clusters resemble what our own stellar nursery may once have looked like billions of years ago. If distant civilizations exist somewhere in the galaxy, perhaps they too orbit stars born beside countless siblings. Perhaps they also look up and wonder where their stellar family went. The universe is full of separations. Galaxies drift apart. Stars leave their birthplaces. Planets wander through darkness. Even light itself spends millions of years traveling alone between worlds. And yet, hidden inside that loneliness are connections stretching across unimaginable distances. The Sun still carries the chemistry of its birthplace. Earth still carries the material of ancient stars. You yourself are part of that chain. Atoms forged in forgotten stellar siblings now exist inside your body. Tonight, while the Sun rests below the horizon on your side of Earth, its lost brothers and sisters may still shine somewhere beyond the visible sky. Tiny points of light among billions, unrecognizable now, scattered beyond reunion, but still connected through a shared beginning deep in the ancient Milky Way. And perhaps that is one of the quietest truths in astronomy. Even stars have families. Even the Sun once belonged somewhere. And somewhere in the darkness beyond our sight, its long-lost siblings are still drifting through the galaxy beside us, carrying the memory of a birthplace that vanished billions of years ago. Somewhere in the vastness of the Milky Way, there may be stars that once drifted beside our Sun in the same glowing nursery of gas and dust. They were born together billions of years ago, before Earth existed, before the planets formed, before the oceans or the moon or life itself. And even now, after all this time, some of those lost stellar siblings may still be shining quietly somewhere in the galaxy, waiting to be found. The idea sounds almost poetic, that the sun, which feels so familiar and solitary in our sky, may actually belong to a scattered family hidden among billions of stars. But this is not simply imagination. Astronomers genuinely believe these siblings exist, and humanity is trying to find them. The search begins with a simple truth about stars. Every star carries a chemical signature from the cloud that formed it. When a giant molecular cloud collapses, the newborn stars inherit the same mixture of elements, almost like children sharing traits from a common ancestor. The proportions of iron, calcium, carbon, magnesium, and other elements become a kind of stellar fingerprint. If two stars formed together long ago, their chemical patterns should still resemble one another even billions of years later. That means the sun's lost siblings may still carry traces of the same ancient birthplace, hidden inside their light. Astronomers use spectroscopy to study these fingerprints. By splitting starlight into spectra, scientists can measure tiny absorption lines created by different elements inside the star's atmosphere. Every star becomes a coded message, a cosmic identity card written in light. But chemistry alone is not enough. The Milky Way contains hundreds of billions of stars, and many can appear superficially similar to the sun. To narrow the search, astronomers also study stellar motion. Stars born together often begin with similar trajectories through space. Although billions of years of galactic motion scatter them widely, traces of their original movement can still remain. This is where modern astronomy becomes astonishingly precise. The European Space Agency Gaia mission has measured the positions and velocities of more than 2 billion stars across the Milky Way. It tracks tiny movements with such accuracy that scientists can reconstruct how stars travel through the galaxy over time. In a sense, Gaia allows humanity to rewind portions of the Milky Way's history, to trace ancient paths backward through billions of years, to search for families that disappeared long before humans existed. And somewhere inside that immense map may be the sun's forgotten brothers and sisters. A few possible candidates have already been identified. Some stars appear remarkably similar to the sun in age, composition, and motion. One candidate, known as HD 162826, attracted attention because its chemistry closely resembles our sun's, suggesting they may once have formed together inside the same stellar cluster. But certainty remains difficult. The galaxy is dynamic and chaotic. Stars are constantly pulled by gravity, disturbed by spiral arms, giant molecular clouds, and close encounters with other stars. Over billions of years, even siblings become almost impossible to recognize. Imagine trying to find a childhood friend after being separated for 4.5 billion years in an endlessly shifting cosmic ocean. That is the challenge astronomers face. Still, the search continues, because finding the sun's siblings could reveal something profound about our own origins. Scientists believe the environment in which the sun formed may have influenced the early solar system itself. Nearby massive stars could have exploded as supernovas, enriching the newborn planets with heavy elements. Perhaps one of the sun's siblings died violently nearby, scattering radioactive material into the cloud that eventually became Earth. If so, our planet carries the ashes of those ancient stars within it, the gold in jewelry, the iron in blood, the oxygen in every breath, all inherited from stellar generations long gone. There is also another fascinating possibility. If the sun's siblings formed from the same cloud, perhaps some of them developed planetary systems too. Maybe distant Earth-like worlds orbit those stars even now. Maybe somewhere far across the Milky Way, another planet circles one of the sun's lost siblings beneath a completely different sky. A parallel solar family scattered across the galaxy. The thought feels strangely comforting, because it reminds us that the sun's story is not isolated. It belongs to something larger, and so do we. Human beings often think of ourselves as separate from the cosmos, as if we merely observe it from afar. But astronomy keeps revealing the opposite. we are deeply connected to these ancient processes. The Sun formed from recycled stardust. Earth formed from the debris of older explosions. Life emerged from chemistry shaped by cosmic history. Even our atoms remember the galaxy. Tonight, while you rest beneath the quiet glow of distant stars, the Milky Way continues turning slowly around us. Somewhere in its spiral arms, hidden among countless lights, stars with the same birthplace as our Sun may still be orbiting silently through the darkness. Some may have planets, some may already be dying. Others may continue shining steadily for billions of years to come, and none of them know they are family. That is one of the strangest things about the universe. Connection can survive even after separation becomes impossible to see. Gravity scatters stars, time erases clusters, galaxies evolve and change. Yet the chemistry of a shared beginning remains hidden inside the light forever. Perhaps that is why astronomers keep searching, not only for data or measurements, but for origins. For the story of where our Sun came from, for the forgotten structure of a family that dissolved before Earth was born. And maybe, in a quiet way, the search also reflects something deeply human: the desire to know where we belong, the desire to understand our roots, the hope that even in an unimaginably vast universe, we are still connected to something beyond ourselves. If this journey through the hidden history of the Milky Way makes you feel both relaxed and quietly curious about your own place in the cosmos, don't forget to leave a like and continue drifting through this series with me. Because somewhere beyond tonight's sky, the Sun's lost family is still wandering through the galaxy. And perhaps one day, humanity will finally recognize them. There is something strangely fragile about the Milky Way that most people never imagine. When we picture our galaxy, we usually see a perfect spiral suspended in darkness. Calm, symmetrical, eternal. A vast wheel of stars turning smoothly through the universe. But the truth is far less stable. The Milky Way is wobbling. Not violently, not fast enough for human eyes to notice. But slowly, continuously, the enormous disk of our galaxy bends and ripples through space like water disturbed by an unseen hand. And once you realize that, the galaxy suddenly feels less like a machine and more like a living thing. Right now, as you lie quietly beneath the night sky, the Milky Way is not perfectly flat above you. Its outer regions are warped upward on one side and downward on the other. The entire galactic disk appears slightly twisted, almost like a giant vinyl record left too long in the heat. This distortion stretches across tens of thousands of light years, and no one noticed it at first. For a very long time, astronomers assumed galaxies were mostly stable structures, elegant spirals rotating peacefully through cosmic time. But as radio telescopes improved and scientists began mapping hydrogen gas far beyond the visible stars, a strange pattern emerged. The outer disk of the Milky Way didn't line up evenly. It curved. The farther researchers looked toward the galaxy's edge, the more obvious the warp became. Stars, gas clouds, and dust no longer followed a perfectly level plane. Instead, they drifted upward and downward in a slow cosmic wave. It was as though the galaxy itself had been gently bent. No one knows with complete certainty what caused it. Some astronomers believe nearby dwarf galaxies may be responsible. Small companion galaxies orbiting the Milky Way exert gravitational forces over immense periods of time. One of the biggest suspects is the Large Magellanic Cloud, a satellite galaxy traveling alongside us through space. Although tiny compared to the Milky Way, its gravity may still be strong enough to tug on our galactic disk, like a passing boat creating waves across a quiet lake. Others think dark matter may play a role. The Milky Way is surrounded by an enormous halo of invisible matter extending far beyond the stars we can see. If that halo is uneven or shifting, its gravity could distort the galaxy from beneath, subtly pulling the disk out of alignment over billions of years. Some scientists even suspect ancient collisions are still echoing through the structure today. Long ago, smaller galaxies crashed into the Milky Way and were absorbed into it. Their stars scattered, their gas merged into ours. Their gravity disturbed the balance of the disk. And perhaps the galaxy never fully settled afterward. The wobble may be the lingering memory of those ancient impacts, a scar moving through starlight. What makes this even stranger is that the warp itself appears to rotate. Not quickly, but slowly drifting around the galactic center, like a giant wave traveling through an ocean of stars. Entire regions of the Milky Way rise and fall over time in a motion so enormous that one full cycle may take hundreds of millions of years. Human civilization has existed for only a tiny fraction of that. We are too brief to notice the movement directly. To us, the stars seem fixed and permanent. But on galactic timescales, the Milky Way is flowing, flexing, and reshaping itself continuously. Even our own solar system participates in this motion. The Sun orbits the center of the galaxy once every roughly 230 million years. During that journey, it moves through regions of differing density, drifting slightly above and below the galactic plane, like a horse riding gentle swells across a dark cosmic sea. Earth has likely crossed these waves many times throughout its history. Dinosaurs lived beneath a different galactic sky than we do now, and long after humanity disappears, the wobble will continue. The galaxy's motion is not limited to its stars alone. Hydrogen gas across the outer disk forms rippling structures that resemble waves spreading across water after a stone is dropped into it. Some regions appear compressed, while others stretch thin. Spiral arms subtly shift position. Clouds of gas tumble through distorted orbits. The galaxy is not rigid, it breathes. Modern surveys from missions like Gaia have allowed astronomers to track the motions of millions of stars with extraordinary precision. And what they discovered was astonishing. Stars across the Milky Way are moving in coordinated vertical patterns, drifting upward and downward together like schools of fish carried by underwater currents. It suggests the galaxy may still be responding to a past gravitational disturbance. Some researchers think a dwarf galaxy passed through the Milky Way long ago, punching through the disk and sending waves rippling outward that still haven't faded. Imagine dropping a pebble into a pond. Now imagine the pond is 100,000 light-years wide, and the ripples last for hundreds of millions of years. That is the scale of what may be happening around us. Yet, despite all this movement, the night sky still feels calm. That may be the strangest part. From Earth, the stars seem steady and peaceful. The Milky Way stretches overhead like a quiet river of pale light. Nothing about it suggests instability or motion. But appearances in the universe are often deceptive. Underneath that tranquil glow, billions of stars are racing through space. Gravitational tides pull at entire regions of the galaxy. Invisible dark matter shapes the motion of everything we see. Ancient collisions continue echoing through the disk, and the galaxy gently wobbles onward. Perhaps there is something comforting about that. Even structures as enormous as galaxies are not frozen. They shift, they bend, they carry scars from the past and adapt to forces they cannot avoid. In some strange way, the Milky Way behaves less like a static object and more like a living memory, a drifting organism made of stars. Tonight, while you rest beneath its light, the galaxy continues its slow motion dance. The outer disk rises and falls. Invisible waves move through the halo. Ancient gravitational tides quietly reshape the structure around us. And Earth travels with it, a tiny world riding a wobbling spiral through the dark. Far above your thoughts, beyond the clouds and beyond the atmosphere, the Milky Way continues to bend like water beneath the weight of unseen things. There is a quiet violence hidden inside every galaxy. Not the kind made by explosions or blazing supernovas. Not the sudden destruction of planets or the collapse of stars into black holes. But a slower force, a patient force. One that stretches entire clusters of stars apart over millions of years until they unravel like threads drifting loose in the dark. The Milky Way creates tides, not tides of water like the oceans on Earth, but tides made from gravity itself. And those tides are powerful enough to tear star systems apart. Right now, far beyond the familiar constellations above your head, enormous rivers of stars are being pulled across the galaxy. Ancient clusters are slowly dissolving. Dwarf galaxies are being stretched into long, glowing streams. The Milky Way does not always destroy violently. Sometimes it simply pulls and keeps pulling until structures that survived for billions of years quietly come undone. Gravity is never perfectly even. That is the secret behind tides. On Earth, the moon's gravity pulls more strongly on the side of the planet facing it than on the opposite side. This tiny difference stretches the oceans, creating rising and falling tides across the world. Now imagine the same effect on a cosmic scale. The Milky Way contains hundreds of billions of stars, vast clouds of gas, invisible dark matter, and an enormous gravitational field stretching across more than 100,000 light-years. Anything moving through that field feels different gravitational forces depending on its position. And over time, those differences begin to pull things apart. Globular clusters are among the oldest objects in the galaxy. These dense spherical groups contain hundreds of thousands of stars packed tightly together, orbiting the Milky Way like ancient lanterns in the halo. Some formed nearly as early as the galaxy itself. For billions of years, they remained stable. But stability in the universe is rarely permanent. As these clusters orbit the galaxy, the Milky Way's tidal forces slowly tug on them. Stars near the outer edges feel weaker attachment to the cluster than stars near the center. Little by little, some drift away. At first, the losses are tiny. A single star escaping here, another slipping free there. But over immense periods of time, the effect grows larger. Eventually, entire streams of stars begin trailing behind the cluster like glowing smoke. Astronomers have discovered these stellar streams stretching across enormous distances in the sky. Some span tens of thousands of light-years, faint rivers of stars marking the paths of structures slowly being dismantled by gravity. They are the remains of ancient systems unraveling before our eyes. One of the most haunting things about these streams is their beauty. From a distance, they look delicate and peaceful, thin ribbons of light drifting silently through darkness. But each one is evidence of destruction happening on a scale almost impossible to imagine. The galaxy is carefully pulling itself apart and rebuilding itself at the same time. Dwarf galaxies experience this process even more dramatically. The Milky Way is surrounded by smaller companion galaxies orbiting it like moths around a lantern. Some survive for billions of years, others wander too close. When that happens, tidal forces begin to stretch them. Their stars no longer orbit neatly within the dwarf galaxy itself. Instead, gravity pulls them outward into long arcs wrapping around the Milky Way. Eventually, the original galaxy may disappear completely, not destroyed in an explosion, not shattered instantly, but slowly smeared across space until all that remains is a ghostly stream of stars orbiting our galaxy forever. The Sagittarius dwarf galaxy is experiencing this right now. It has been passing through the Milky Way repeatedly for billions of years, and each encounter strips away more of its stars. Today, enormous stellar streams from this galaxy wrap around the Milky Way like pale ribbons, evidence of a long gravitational consumption still unfolding. In a way, galaxies feed on smaller galaxies, and the process is astonishingly quiet. No sound accompanies the destruction. No sudden flash marks the moment a star is lost forever from its original home. Only motion, only gravity, only time. Even individual stars can become victims of tidal forces. Near the supermassive black hole at the center of the Milky Way, gravity becomes so intense that stars passing too close may be stretched violently. The side nearest the black hole feels a much stronger pull than the far side. This creates what astronomers call tidal disruption. The star elongates, gas is stripped away. Sometimes the entire star is torn apart completely, its material spiraling into the darkness while releasing enormous bursts of radiation. A star can spend millions or billions of years shining peacefully. only to end as a stream of glowing debris circling an invisible abyss. Yet, tidal destruction is not always catastrophic. Sometimes it is strangely creative. When galaxies merge, tidal forces can trigger waves of star formation. Gas clouds collide and compress. New stars ignite. Entire stellar nurseries appear within the chaos. The same gravity that destroys old structures can also create new ones. This cycle repeats throughout cosmic history. Galaxies collide, clusters dissolve, stars scatter. New systems form from the remains. The universe constantly rearranges itself through these invisible currents of gravity. And perhaps the most unsettling part is how slow it all happens. Human lives are too short to notice the motion directly. To us, the stars appear eternal and fixed. But over millions of years, constellations distort. Clusters disperse. Entire galaxies change shape. The night sky you know is temporary. Even the Milky Way itself will not remain unchanged forever. 4 billion years from now, our galaxy and the Andromeda Galaxy will begin merging together. Their tidal forces will distort both galaxies into enormous arcs of stars and gas. Spiral arms will stretch and twist. Stellar streams will spill outward into space. The calm ribbon of the Milky Way overhead will someday become unrecognizable. And yet, amid all this change, gravity also creates connection. The same force tearing clusters apart is the force holding Earth in orbit around the Sun. It guides galaxies through space. It shapes the cosmic web itself. Creation and destruction emerge from the same invisible hand. Tonight, somewhere far beyond human sight, another ancient star cluster is slowly unraveling. A dwarf galaxy is shedding stars into the halo. Invisible tidal forces continue their patient work across the Milky Way, and Earth drifts quietly within it all. A tiny world suspended inside a galaxy whose gravity is forever pulling, stretching, reshaping, and rewriting the stars. There is something strangely humbling about this fact. Human beings have mapped distant planets, photographed black holes, and measured light that began traveling before Earth even existed. And yet, we still do not know exactly how much our own galaxy weighs. The Milky Way is our home. It contains hundreds of billions of stars, enormous rivers of gas, ancient star clusters, invisible magnetic fields, wandering planets, black holes, and vast clouds of dust stretching across more than 100,000 light years. But when astronomers try to answer one surprisingly simple question, how heavy is it? The universe becomes uncertain again. Right now, scientists estimate that the Milky Way may weigh around 1 trillion times the mass of the Sun. Maybe more. Maybe much more. And the reason for this uncertainty reveals one of the strangest truths in modern astronomy. Most of the galaxy is invisible. If you could somehow travel far beyond the Milky Way and look back at it from deep space, you would see a glowing spiral of stars suspended in darkness, bright arms curling outward, dense clouds near the center, faint clusters orbiting the edges. But what you would see is only a fraction of what is actually there. The stars themselves account for surprisingly little of the galaxy's total mass. Even the gas and dust between the stars contribute only a small percentage. The overwhelming majority appears to come from something we cannot directly observe: dark matter. This mysterious substance does not glow, reflect light, or interact normally with matter. It is invisible to telescopes. We cannot touch it, photograph it, or isolate it in laboratories. And yet its gravity shapes entire galaxies. Without dark matter, the Milky Way should fly apart. Stars near the outer edges of the galaxy orbit far too quickly to be held in place by visible matter alone. According to the laws of gravity, those stars should drift away into intergalactic space. But they don't. Something unseen is holding everything together. Imagine watching leaves spinning around a tree in complete darkness. You cannot see the tree itself. You only know it exists because of the motion around it. That is how astronomers study dark matter. They measure how stars move. The faster stars orbit, the more mass must exist inside their orbits. By observing these motions across the galaxy, scientists try to estimate the Milky Way's total weight. But this is incredibly difficult. We live inside the galaxy itself. That means we cannot simply step back and weigh it from afar. Instead, astronomers must piece together clues from within, like trying to determine the size of a forest while standing among the trees. One method involves tracking the movement of globular clusters and satellite galaxies orbiting the Milky Way. These objects act like test particles moving through the galaxy's gravitational field. If they move quickly, the galaxy must be more massive. If they move slowly, it may weigh less. But measurements are incomplete. Distances are uncertain. Some objects may not even be gravitationally bound to the Milky Way at all. Every answer comes with enormous margins of error. Even the shape of the dark matter halo surrounding the galaxy remains mysterious. Astronomers believe the Milky Way is embedded inside a gigantic halo of dark matter extending far beyond the visible stars. This halo may stretch for millions of light years, surrounding the galaxy like an invisible ocean. But no one knows its exact structure. Is it smooth? Clumpy? Symmetrical? Tilted? Still changing? The uncertainty affects everything. It influences predictions about the Milky Way's future collision with the Andromeda Galaxy. It changes estimates of how galaxies form and evolve. It affects the motion of satellite galaxies and the behavior of stellar streams drifting through the halo. Even our understanding of cosmic history depends partly on this invisible mass. And despite decades of study, dark matter itself remains one of the greatest mysteries in science. Some theories suggest it consists of unknown particles drifting silently through space. Others propose entirely new forms of physics beyond our current understanding. There are even ideas that gravity itself may behave differently on galactic scales. The fact that we still debate these possibilities is astonishing, because it means humanity is living inside a structure we do not fully understand. There is also something deeply poetic about that. For centuries, people believed the stars were fixed points of light placed upon a perfect celestial sphere. Later, we learned the Milky Way was a galaxy among billions. Then we discovered black holes, expanding space, gravitational waves, and dark energy. Each discovery made the universe larger and stranger. And now we realize that even our own galaxy is mostly hidden from us. Invisible matter outweighs everything we can see. The atoms in your body, the planets, the stars, the glowing clouds of nebulae, all of it combined may represent only a small fraction of what truly exists within the Milky Way. The galaxy is heavier than light itself suggests. That idea changes the emotional feeling of the night sky. When you look upward, you are not seeing the whole galaxy, you are only seeing its luminous skin. Beneath and around those visible stars lies an enormous, unseen structure, shaping everything through gravity alone. A silent framework holding the spiral together while remaining forever hidden from human eyes. In a strange way, the Milky Way resembles memory itself. What is visible is only part of the story. The deeper forces remain unseen. Tonight, as Earth continues its quiet orbit around the Sun, our entire solar system drifts through this invisible sea of mass. The galaxy spins around us, held together by gravity we still cannot fully explain. Somewhere in the outer halo, distant stars orbit through darkness we cannot detect directly. Satellite galaxies move along paths carved by unseen matter. Stellar streams curve through gravitational fields hidden from sight. And humanity, small and temporary within it all, continues trying to weigh the darkness surrounding its own home. Perhaps that is one of the most beautiful parts of astronomy. The more we learn about the universe, the more mystery remains. For a very long time, humanity assumed there was a larger giant waiting for us in the dark, a galaxy bigger than our own, brighter, wider, more massive. The great spiral of Andromeda Galaxy has always seemed like the older, stronger sibling of the Milky Way. Even through small telescopes, Andromeda appears enormous, stretching across space with a brilliant core and vast spiral arms glowing softly in the night. Compared to it, the Milky Way feels quieter, more modest, less dramatic. But the universe has a habit of hiding its true weight beneath calm appearances. And now, astronomers are beginning to suspect something unexpected. The Milky Way may actually be heavier than Andromeda. At first, that sounds impossible. Andromeda contains more visible stars. Its galactic disk appears larger. Its central bulge shines more brightly. For decades, nearly everyone assumed it must also contain more mass. It simply looked bigger. But galaxies are deceptive things. As astronomers learned while studying dark matter, what you see is not always what matters most. A galaxy's true weight is determined not only by its stars, but by the invisible halo of dark matter surrounding it. This hidden structure extends far beyond the glowing spiral arms, forming an enormous gravitational cocoon around the galaxy. And those halos may tell a very different story. Recent measurements suggest the Milky Way's dark matter halo could be broader and denser than previously believed. If that is true, our galaxy may outweigh Andromeda, even while appearing smaller in visible light. It would be like discovering that a quiet mountain hidden in fog is heavier than the towering peak beside it. The difference lies beneath the surface. Astronomers estimate galactic mass by studying motion. They observe how fast stars orbit around galactic centers. They track dwarf galaxies moving through surrounding space. They examine globular clusters drifting in distant halos. Every orbit becomes a clue about the gravity shaping it, and gravity reveals mass. The faster objects move, the more hidden weight must exist to hold them in place. For years, Andromeda appeared dominant because of its visible structure. But as instruments improved and data became more precise, scientists noticed something surprising. The Milky Way's outer halo may contain far more dark matter than expected. Some studies suggest its total mass could rival or even exceed Andromeda's. Others still argue Andromeda remains larger. The truth is that astronomers are not entirely certain yet, and there is something strangely beautiful about that uncertainty. Two gigantic galaxies, each containing hundreds of billions of stars, are moving toward one another through the darkness of space. They are the largest members of our local cosmic neighborhood, the Local Group, and humanity still debates which one is heavier. It feels almost human somehow. Two silent giants approaching each other across millions of light years, while tiny creatures on a small planet attempt to measure them from within one fragile spiral arm. The future collision between the Milky Way and Andromeda depends heavily on these unknowns. Right now, Andromeda is moving toward us at roughly 110 kilometers per second. In about 4 billion years, the two galaxies will begin to merge, but the details of that encounter remain uncertain. If Andromeda is heavier, it may dominate the merger, reshaping the Milky Way more dramatically. If the Milky Way carries greater mass in its dark halo, the collision could unfold differently, with our galaxy exerting more gravitational influence than expected. Entire futures depend on invisible matter we still cannot directly see. The galaxies themselves are already feeling each other's pull. Even now, their dark matter halos may be overlapping faintly through intergalactic space, stretching toward one another long before the visible stars ever meet. It is possible that the merger has already begun in ways invisible to human eyes. When people imagine galactic collisions, they often picture catastrophic explosions and stars smashing together like cars in traffic. But galaxies are mostly empty space. When the Milky Way and Andromeda merge, very few stars will actually collide directly. Instead, gravity will reshape both systems slowly over billions of years. Spiral arms will distort, stellar streams will form, gas clouds will compress and ignite waves of new star formation. The night sky from future Earth, if Earth still exists, would become almost unimaginable. Andromeda would slowly grow larger over millions of years until it dominates the heavens. Eventually, the two galaxies would intertwine into one vast, distorted structure, before settling into a new shape entirely. perhaps a giant elliptical galaxy, perhaps something stranger. And hidden underneath all of it will be dark matter, guiding the dance silently. That may be the most unsettling part. The largest structures in our cosmic neighborhood are controlled mostly by something we cannot see. The Milky Way may appear softer and calmer than Andromeda, but appearances mean little in the universe. Beneath its quiet spiral arms may lie an immense reservoir of invisible mass shaping everything around it. A hidden giant disguised as a peaceful galaxy. There is also something comforting in realizing that even galaxies have unseen depths. Human beings often mistake brightness for importance. We assume louder things are stronger. We trust appearances too easily. But the cosmos reminds us again and again that the invisible can outweigh the visible. Quiet things can carry enormous gravity. Tonight, somewhere beyond the stars overhead, Andromeda continues its slow approach toward us. Its light has traveled more than 2 million years to reach Earth. Long before humans existed, those photons began crossing the dark between galaxies. And still they arrive. Meanwhile, the Milky Way turns silently around us, carrying perhaps more weight than we ever imagined. Its stars drift through invisible oceans of dark matter. Its halo stretches far into the darkness beyond what human eyes can perceive. Two great galaxies move toward each other now, two spirals suspended in silence. And somewhere deep within the hidden gravity between them, the future of our cosmic home is already unfolding. For most of human history, the night sky seemed permanent. The stars rose and fell in familiar patterns. The Milky Way stretched across the darkness like a river of pale light. Even distant galaxies appeared fixed and eternal, frozen in their places beyond time. But the universe is not still. Everything is moving, and some of the galaxies closest to us may not have been here for very long at all. Hanging in the southern sky are two faint glowing companions known as the Large Magellanic Cloud and the Small Magellanic Cloud. To ancient skywatchers, they looked like detached fragments of the Milky Way, mysterious patches of light floating alone in the darkness. Sailors navigating southern oceans used them as celestial markers. Early astronomers studied them through primitive telescopes, wondering what they truly were. Today, we know they are dwarf galaxies orbiting our own. But there is something strange about them. They may not be longtime companions of the Milky Way after all. They may be visitors. And perhaps they are only now arriving for the first time. For decades, astronomers assumed the Magellanic Clouds had circled the Milky Way many times across billions of years. That seemed natural. Small galaxies often become trapped in orbit around larger ones, slowly dancing around them through cosmic time. But modern measurements have complicated that picture. Using incredibly precise data from telescopes and space missions, astronomers began tracking the motion of the Magellanic Clouds more carefully than ever before. And what they found was surprising. The galaxies appear to be moving much faster than expected, fast enough that they may not have completed multiple orbits around the Milky Way at all. Instead, some scientists now believe the clouds could be making their very first close approach to our galaxy. If true, this changes the emotional feeling of the night sky completely. Those faint, glowing companions overhead are not ancient permanent fixtures of our galactic family. They are newcomers arriving from deep space, travelers crossing the darkness between galaxies. The Large Magellanic Cloud alone contains billions of stars. Though far smaller than the Milky Way, it is still an enormous structure, carrying clusters, nebulae, dark matter, and stellar nurseries across the universe like a drifting island of light. And it may only recently have fallen under the Milky Way's gravitational influence. Imagine the scale of that moment, an entire galaxy entering another galaxy's realm. Not in a sudden collision, but in a gradual gravitational encounter unfolding over hundreds of millions of years. Even now, the Milky Way appears to be reacting to their arrival. Astronomers believe the gravity of the Magellanic Clouds may be disturbing the outer regions of our galaxy. Some of the wobbling motion in the Milky Way's disk could be caused by their pull, Ripples detected in stellar motions may be echoes of this interaction spreading through the galaxy. It is as though our entire galaxy can feel the presence of these approaching companions. The night sky itself may carry signs of their arrival. One of the most haunting structures connected to the Magellanic Clouds is the Magellanic Stream, a vast ribbon of hydrogen gas trailing behind them through space. This stream stretches for hundreds of thousands of light years across the sky. Invisible to human eyes, detectable only through radio telescopes, it is thought to have formed as tidal forces pulled gas away from the dwarf galaxies during their interactions with each other and with the Milky Way. A long cosmic trail, a river of stolen matter flowing silently through the darkness. Some astronomers believe this gas may eventually fall into the Milky Way itself, helping fuel future star formation. In that sense, the arriving galaxies may already be feeding our own. The Milky Way is not isolated. It is constantly changing through encounters like these. Galaxies grow by absorbing smaller companions. Streams of stars wrap around halos. Gas drifts between systems. Gravity slowly rearranges the architecture of the cosmos. And the Magellanic Clouds may represent a moment of galactic transformation still unfolding. There is something strangely emotional about that idea. When we look at the night sky, we often imagine we are seeing ancient stability. But perhaps we are actually witnessing movement, migration, and arrival. The universe is filled with travelers. Even galaxies wander. The Large Magellanic Cloud is also home to one of the most active star-forming regions near the Milky Way, the Tarantula Nebula. Within its glowing clouds, massive stars are being born in violent bursts of light and radiation. Some of those stars will eventually explode as supernovae. Others may collapse into black holes. Entire future solar systems are forming there right now, and all of it drifts alongside our galaxy like a neighboring city crossing the dark ocean of space. One day, the Magellanic Clouds may not survive intact. Over immense stretches of time, the Milky Way's gravity could gradually tear them apart. Their stars may disperse into the galactic halo. Their gas may merge with ours. Their structures may dissolve into stellar streams wrapping around the galaxy. They may become part of the Milky Way completely. Not through violence alone, but through gravity's slow patience. The universe often transforms things gently. Tonight, somewhere far above the southern horizon, the Magellanic Clouds continue their silent approach. Billions of stars drift together through darkness, carrying their own histories, worlds, and ancient light. And the Milky Way waits around them like a vast gravitational sea. Perhaps that is what galaxies truly are. Not isolated islands frozen forever in space, but wandering structures meeting, merging, and reshaping one another across the endless dark. Even now, our galaxy may still be greeting new arrivals. Far beyond the visible stars, trailing behind the large and small Magellanic Clouds, there is something almost ghost-like drifting through space. Not a chain of glowing suns, not a bright spiral arm, but a river of invisible hydrogen gas stretching across the darkness for hundreds of thousands of light years. Astronomers call it the Magellanic Stream, and even though most human eyes will never see it, this enormous ribbon may be one of the clearest signs that galaxies are not isolated islands at all. They pull on each other, they wound each other, they leave scars across space. The night sky often feels calm from Earth. The stars appear fixed. The constellations barely change within a lifetime. But on the scale of galaxies, everything is moving. Slowly, silently, relentlessly. The Magellanic Clouds themselves are small satellite galaxies orbiting near the Milky Way. From the southern hemisphere, they appear as faint, glowing patches floating beside our galaxy's bright river of stars. Ancient sailors once used them as guides in the night sky. To the naked eye, they seem peaceful and distant, but hidden behind them is evidence of an ongoing gravitational struggle. As these dwarf galaxies moved through space, the immense gravity of the Milky Way began pulling at them. At the same time, the two clouds pulled at each other as well. Over millions and billions of years, those tidal forces stretched vast amounts of hydrogen gas outward, like strands being pulled from soft fabric. That stolen gas became the Magellanic Stream. Imagine two islands drifting through a cosmic ocean while long trails of mist are torn away behind them. That is essentially what astronomers believe happened here. The stream is not solid. It is incredibly thin and diffuse, yet its scale is almost impossible to comprehend. If the stream were visible to human eyes, it would stretch across a huge portion of the sky. But hydrogen gas at such low density does not shine brightly in visible light. Instead, astronomers detect it mostly through radio observations. Giant radio telescopes scan the sky and translate faint signals into maps. Slowly, a hidden structure emerges, a winding river of gas curling behind the Magellanic Clouds, like smoke drifting behind ships at sea. For decades, scientists tried to understand how this stream formed. Some evidence suggests that the large and small Magellanic Clouds interacted violently with each other before even approaching the Milky Way closely. Their mutual gravity may have stripped gas away long before our galaxy became involved. Later, the Milky Way's gravitational pull stretched the material even farther. The result is one of the largest known gaseous structures connected to our galaxy. And it is still moving. Even now, this ribbon continues to drift through space, slowly wrapping around the Milky Way's outer regions. Portions of it may eventually fall into our galaxy itself. If that happens, the gas could help fuel future star formation. In a strange way, the stream may become part of future generations of stars. Somewhere billions of years from now, new suns could ignite using material once torn from a passing dwarf galaxy. That idea changes how we think about galaxies. We often imagine them as permanent structures, but galaxies are constantly exchanging matter. They feed on smaller companions, they absorb gas, they merge, they grow through collisions and slow gravitational theft. The Milky Way itself may owe much of its present structure to ancient mergers that happened long before Earth existed. And the Magellanic Stream is evidence that the process is still happening. There is something haunting about the stream, because it represents both destruction and creation at the same time. The gas was stripped away violently. Entire regions of the dwarf galaxies were disrupted by tidal forces. Yet the stolen material may someday become the birthplace of entirely new stars and planets. Cosmic history often works that way. Death becomes raw material for future light. What makes the Magellanic Stream especially mysterious is how little we still understand about it. Some regions appear fragmented and turbulent. Others show signs of interaction with the Milky Way's hot halo gas. There may even be hidden magnetic fields shaping parts of the structure. The stream is not just floating passively through emptiness. It is interacting continuously with its environment. As it moves through the halo surrounding our galaxy, pressure and friction slowly tear pieces away. Clouds fragment, filaments twist. Portions evaporate into the surrounding medium. It resembles smoke dissolving into wind. And yet, the stream persists. Across unimaginable distances, this faint ribbon continues tracing the history of gravitational encounters that began hundreds of millions of years ago. There is also something deeply humbling about realizing how invisible most of the galaxy truly is. If humans could only rely on visible light, we would never know the Magellanic Stream existed. Entire structures larger than star systems remain hidden from ordinary sight. Only through radio astronomy have we learned to uncover these ghostly rivers in the dark. The universe is filled with things we cannot naturally perceive. Invisible hydrogen, invisible magnetic fields, invisible dark matter, invisible radiation crossing space every second. And yet, all of them shape the cosmos around us. The Magellanic Stream reminds us that galaxies are alive with motion even when they appear still. Beneath the calm beauty of the night sky, enormous forces are constantly stretching, tearing, feeding, and reshaping the universe. Even our own Milky Way is not untouched. The arrival of the Magellanic Clouds may already be disturbing our galaxy's outer disk. Some astronomers believe their gravity contributes to the slight warp observed in the Milky Way's shape. In other words, these small neighboring galaxies may literally be bending part of our galaxy as they pass nearby. The sky above us feels eternal and unmoving, but in reality, it is fluid. Galaxies drift, gas streams flow, stars orbit. Gravity pulls silently across millions of light years. And hidden among those motions is a river of hydrogen stretching through darkness, marking the path of galaxies that wandered too close to something larger than themselves. Tonight, while Earth turns quietly beneath your window, the Magellanic Stream is still there beyond human sight. A faint cosmic ribbon drifting through the outer reaches of the Milky Way. A reminder that even galaxies leave trails behind them. Like footprints in an ocean too vast to fully see, some of the strangest motions inside the Milky Way are not random at all. They are scars, ancient marks left behind by collisions so old that they began long before Earth even existed. The galaxy remembers every impact, not with sound, not with fire still burning in the sky, but through motion. Even now, billions of years later, stars continue traveling along unusual paths carved out by encounters from the distant past. Invisible rivers of stars drift through the halo. Clusters stretch apart like pulled threads. Entire populations of suns move differently from everything around them. These are the fossils of cosmic collisions. When we look at the Milky Way at night, it appears calm and permanent, a soft river of light crossing the darkness. But our galaxy did not form peacefully. It grew through mergers, disruptions, and gravitational encounters over billions of years. Smaller galaxies once wandered too close, and the Milky Way consumed them. Astronomers now believe that much of our galaxy was built this way. Long ago, dwarf galaxies carrying their own stars, gas, and dark matter drifted through space until gravity pulled them inward. Some were torn apart completely, their stars scattered into long streams wrapping around the Milky Way like ghostly ribbons. The original galaxies vanished, but their motions remained. Today, scientists can still detect those ancient victims by studying how stars move. Most stars in the Milky Way follow predictable orbits around the galactic center, but some travel at unusual angles. Others move in giant, elongated loops, far above and below the galactic disk. Certain groups share the same velocity and chemical composition, even though they are now spread across enormous distances. That should not happen naturally. It suggests those stars were once part of something larger. Like fragments of shattered glass still traveling outward after an impact, they preserve the memory of destruction. One of the most remarkable discoveries came from data collected by the Gaia spacecraft. By mapping the motions of billions of stars with extraordinary precision, astronomers uncovered evidence of ancient collisions hidden throughout the galaxy. Among the most famous is a past merger scientists sometimes call Gaia Enceladus. Billions of years ago, a dwarf galaxy collided with the young Milky Way. The encounter was catastrophic. Stars were thrown onto chaotic orbits. The structure of the galaxy itself may have changed forever. Some researchers believe this collision helped create parts of the Milky Way's thick disk. In other words, part of our galaxy's modern shape may exist because of an ancient impact from another galaxy, and the evidence is still visible today in the motions of stars around us. There is something deeply eerie about that idea. The night sky above Earth contains survivors of events so old that human civilization cannot even begin to compare. Some stars we see tonight may have once belonged to entirely different galaxies before being captured by ours. They are immigrants from destroyed worlds, travelers carrying ancient histories through the dark. Even globular clusters may be relics of these collisions. These dense spherical swarms, containing hundreds of thousands of stars, orbit far beyond the galactic disk. Some appear older and chemically different from the rest of the Milky Way, suggesting they may have originated elsewhere before being captured during mergers. The galaxy is not a single clean structure. It is layered history. Every strange orbit is like handwriting left across space by gravity itself. And these collisions are not entirely confined to the past. Even now, the Milky Way continues interacting with nearby galaxies. The large and small Magellanic Clouds are affecting the shape of our galaxy as they move nearby. Tidal forces stretch stars and gas into enormous streams. Invisible dark matter halos collide and overlap. The process of galactic evolution is still happening around us, slowly, silently, relentlessly. In the distant future, the greatest collision of all still awaits. The Milky Way and the Andromeda Galaxy are moving toward each other right now. In about 4 billion years, the two giant galaxies will begin merging in a vast gravitational dance. Stars will rarely collide directly because space is so enormous, but their orbits will be rearranged dramatically. Spiral arms may dissolve. New bursts of star formation could ignite across both galaxies. The night sky of future worlds may blaze with unfamiliar light. And eventually, the two galaxies may become one enormous elliptical system. Even that future collision will leave scars, because galaxies never truly forget. Gravity preserves memory in motion. A star may orbit for billions of years, carrying the imprint of an ancient encounter. Long after the original structures vanish, their effects continue echoing through the galaxy like ripples spreading across water. That is one of the most beautiful things modern astronomy has revealed. The universe keeps records. Not on paper, not in language, but in trajectories, in chemistry, in patterns hidden inside the movements of stars. The Milky Way is not frozen in time. It is a living archive written across light years, and we are inside it. Our own solar system has likely traveled through the aftermath of ancient mergers many times during its orbit around the galaxy. The Sun completes one trip around the Milky Way roughly every 230 million years. During that immense journey, it passes through changing regions shaped by events older than multicellular life on Earth. All around us are remnants of forgotten galaxies. We simply do not notice them with human eyes, but telescopes do. Data does. The silent mathematics of motion does. There is something strangely comforting about realizing that destruction in the universe is rarely absolute. Even when galaxies collide and tear each other apart, pieces survive. Streams of stars continue onward. Gas forms new suns. Ancient debris becomes future worlds. The cosmos transforms itself continuously. Nothing stays unchanged. Nothing disappears completely. Tonight, while Earth sleeps beneath the stars, the Milky Way continues carrying the memory of every collision it has ever endured. Ancient stellar streams still orbit through the halo. Hidden scars still curve through the darkness. Ghost galaxies still whisper through the motions of stars. And somewhere inside that vast living structure, our small world drifts quietly onward among the echoes of ancient cosmic impacts. If you enjoy exploring these quiet mysteries hidden inside the galaxy, subscribe and continue this journey through the secrets the universe has carried for billions of years. Hidden deep within the Milky Way are enormous structures that should not exist for very long. Vast shells of gas stretching across hundreds of light years. Giant cavities carved into the interstellar medium. Faint bubbles drifting through darkness like the outlines of vanished explosions. They are the fossils of ancient starbursts, the remains of times when entire regions of the galaxy erupted with furious star formation. When we picture the Milky Way, we often imagine something calm and graceful, a slow spiral of stars quietly turning through the night. But there were periods in the galaxy's history when certain regions became violently active, producing huge clusters of massive stars almost all at once. These were cosmic firestorms, and although the stars themselves may already be dead, their fingerprints still remain written across space. A starburst happens when enormous amounts of gas collapse rapidly, triggering intense waves of star formation. Instead of producing a few isolated stars over millions of years, the region suddenly creates vast stellar nurseries crowded with hot, massive suns. Many of those stars live very short lives. The largest stars burn through their fuel incredibly fast. While smaller stars like our Sun can survive for billions of years, giant stars may last only a few million before exploding as supernovae. And when hundreds or even thousands of massive stars are born together, their deaths begin overlapping. The result is extraordinary. Shock waves crash into surrounding gas clouds. Stellar winds blow outward at enormous speeds. Supernova explosions hammer the interstellar medium repeatedly, pushing material away in expanding fronts. Over time, those combined forces carve gigantic hollow cavities into the galaxy itself. Astronomers have discovered many of these structures throughout the Milky Way. Some appear as immense spherical shells of hydrogen gas. Others resemble enormous bubbles floating above and below the galactic plane. A few stretch so far that they span entire regions between spiral arms. These formations are not random. They are scars left behind by ancient periods of stellar frenzy. In a sense, the galaxy remembers where it once burned brightest. One remarkable example is the enormous bubble-like structures extending from the center of the Milky Way, known as the Fermi bubbles. Towering tens of thousands of light years above and below the galactic core, these gigantic lobes emit high-energy radiation and may be remnants of violent activity from the past. Perhaps they were created by bursts of star formation near the galactic center, or perhaps by eruptions from the supermassive black hole itself. Either way, they reveal that the calm galaxy we see today was once far more turbulent. There is something strangely beautiful about these ancient structures because they resemble echoes frozen in space. The stars responsible for them may already be gone. Many exploded millions of years ago. Yet the shells they created continue expanding slowly through the darkness, like ripples that never completely fade. Some of these bubbles move through the galaxy for tens of millions of years before finally dissolving into the surrounding medium. During that time, they influence everything around them. They compress nearby gas clouds. They trigger new waves of star formation. They redistribute heavy elements created inside dying stars. In other words, the deaths of one generation of stars help shape the birth of the next. The galaxy recycles itself continuously, and these ancient starburst remnants are part of that circulation. Astronomers sometimes compare this process to breathing. Stars form from cold gas clouds. They shine briefly, they explode. Their material spreads outward. Eventually, new clouds collapse again. The Milky Way inhales and exhales across unimaginable spans of time. What makes these stellar fossils especially fascinating is that many are almost invisible in ordinary light. Some can only be detected through radio observations. Others appear in X-rays or infrared wavelengths, where heated gas and dust reveal hidden structures. To human eyes alone, much of this history would remain completely unseen. The galaxy hides its past beneath layers of darkness and dust. But modern telescopes allow us to uncover those buried memories. And the more astronomers study these structures, the clearer it becomes that the Milky Way has lived through dramatic cycles of activity. There were ages when regions of the galaxy blazed with newborn stars far more intensely than they do now. Imagine standing on a world inside one of those ancient starburst regions. The night sky would have looked astonishing. Massive blue stars would dominate the heavens. Nebulae would glow brightly across space. Supernovae might erupt frequently enough to outshine entire constellations. It would not resemble the quiet sky above Earth today. It would feel alive with cosmic fire. Yet even the most violent stellar eras eventually fade. The massive stars die first. Their explosions disperse the gas needed to form future generations. Slowly, the region calms. The brilliant clusters dim. Only expanding shells and scattered remnants remain behind, like ashes after a fire. That is why these structures feel almost archaeological. Astronomers are not only observing the present galaxy, they are excavating its past. Each shell of gas tells a story. Each bubble marks a forgotten age of creation and destruction. Each distorted cloud preserves evidence of stars that no longer exist. The Milky Way is filled with ancient weather, and we are drifting through it. Even our own solar system may have passed through old supernova remnants during its orbit around the galaxy. Some scientists suspect nearby explosions in the distant past may have influenced Earth's environment in subtle ways. The universe is more interconnected than it appears. A dead star exploding millions of years ago can shape future clouds, future suns, future planets, and perhaps even future life. That realization changes the way we see the night sky. The stars above us are not isolated lights. They are participants in an endless cycle stretching across billions of years. Tonight, somewhere in the Milky Way, new clusters of stars are forming inside cold molecular clouds. Massive young suns are already beginning to carve cavities into the surrounding gas with their radiation and stellar winds. Far in the future, those regions too may leave behind enormous fossil bubbles drifting silently through space. And long after the stars themselves disappear, the galaxy will still remember where they once burned. Space feels empty to us because the distances between stars are almost impossible to imagine. Even the nearest star beyond our sun is over 4 light-years away. Most stars in the Milky Way are separated by enormous stretches of darkness, so vast that direct collisions should be incredibly rare. And yet, sometimes stars really do collide. Somewhere in the galaxy tonight, 2 ancient suns may already be spiraling toward one another in silence. Their gravity pulling tighter, their orbits shrinking slowly across millions of years, until eventually, after an unimaginably long dance, they touch. What happens next can reshape entire regions of space. When most people imagine stars, they think of fixed points of light calmly hanging in the sky. But stars are moving constantly. Every star in the Milky Way travels through the galaxy on its own orbit around the galactic center. Some drift quietly through sparse regions of space where encounters are unlikely. Others live in crowded stellar cities. Deep inside globular clusters, conditions become very different. Globular clusters are dense spherical collections containing hundreds of thousands or even millions of stars packed into relatively small volumes. In some regions near their centers, stars may lie only a fraction of a light-year apart. Compared to the emptiness around our sun, these environments are astonishingly crowded. If you stood on a planet inside the core of such a cluster, the night sky would blaze with stars in every direction. There might never be true darkness at all. And in those crowded regions, gravity creates chaos. Stars pass close to one another constantly. Their orbits shift through countless interactions. Over billions of years, some stars eventually collide or merge entirely. The collisions themselves are difficult to imagine because stars are not solid objects like planets. They are enormous spheres of superheated gas held together by gravity. When 2 stars approach each other, tidal forces distort them first. Their outer layers begin stretching and twisting long before direct contact occurs. Then comes the impact. Sometimes the stars merge into one larger star. Sometimes one tears matter away from the other. In especially violent encounters, the collision can release extraordinary amounts of energy. For a brief time, the merged star may shine far brighter than before. Astronomers believe some mysterious objects called blue stragglers are created this way. Blue stragglers are strange stars found in ancient clusters where most stars should already be old and dimmer. Yet these stars appear unusually hot, bright, and young compared to their neighbors. It is almost as if they somehow cheated time. One explanation is that they formed through stellar mergers. 2 aging stars collided and combined, creating a rejuvenated star with fresh hydrogen fuel and renewed brightness. In a way, these stars are reborn from destruction. There is something hauntingly beautiful about that idea. Even among ancient stellar populations, collisions can create something that appears young again. But not all stellar encounters are direct crashes. Many stars exist in binary systems, orbiting each other closely. Over time, those orbits can shrink through gravitational interactions. Eventually, one star may begin pulling material from its companion. This process can become unstable and violent. Gas spirals between the stars in glowing streams. Temperatures rise enormously. In some systems, the stars eventually merge completely. In others, the interaction triggers massive explosions called novae or even supernovae. The galaxy is far more dynamic than the calm night sky suggests. Every point of light carries a story of motion, gravity, and change. Some stellar collisions involve even stranger remnants. When neutron stars collide, the event becomes one of the most energetic phenomena in the universe. These ultra-dense stellar corpses spiral inward while releasing gravitational waves across space itself. Then they merge in a catastrophic explosion known as a kilonova. Heavy elements like gold and platinum are forged in those moments. The atoms inside jewelry on Earth may have originated in ancient stellar collisions billions of years ago. In that sense, part of the human world was born from stars crashing together in darkness long before the sun existed. There is also a quieter side to stellar collisions. Not every encounter ends explosively. Some stars simply exchange momentum, altering each other's paths through space. Others become locked in complex gravitational dances involving 3 or more stars interacting together. Inside dense clusters, these interactions happen repeatedly over immense timescales. The cluster itself evolves almost like a living ecosystem. Stars migrate inward and outward, binary systems form and break apart. Some stars are ejected entirely into interstellar space. Gravity continuously rearranges the structure. Astronomers sometimes describe this process as stellar dynamics, but emotionally it feels more like weather. Invisible currents of gravity slowly shaping crowded stellar environments over billions of years. And while true collisions remain rare across the galaxy as a whole, the Milky Way contains so many stars that rare events still happen surprisingly often on cosmic timescales. There are hundreds of billions of stars here. Even extremely unlikely encounters eventually occur somewhere. Perhaps at this very moment, far beyond human sight, 2 stars are already merging inside a distant cluster, their outer layers blending into one another. The combined gravity creating a new and brighter sun. No human will witness it directly. The galaxy keeps most of its transformations hidden in darkness. But the evidence remains scattered across the sky for those who learn how to read it. Blue stragglers glowing too brightly, unusual stellar remnants, gravitational waves rippling through space-time, chemical fingerprints of violent mergers. The Milky Way quietly records every collision. There is something strangely comforting in realizing that even in a universe filled with emptiness, encounters still happen. Paths still cross. Objects separated by unimaginable distances can eventually meet through the slow persistence of gravity. Nothing in the cosmos is truly frozen. Everything moves. Everything changes. Everything drifts through time. Tonight, while Earth turns beneath the stars, ancient clusters continue their slow gravitational dance deep inside the galaxy. Somewhere in those crowded stellar realms, suns are passing close to one another beneath skies brighter than anything humans have ever seen. And every once in a while, after millions or billions of years of motion, 2 stars finally touch. Not with sound, not with violence we could hear, but with a silent flash of cosmic transformation unfolding far beyond the reach of the sleeping world below. Far beyond the glowing spiral arms of the Milky Way, beyond the quiet rivers of dust and the drifting clouds of hydrogen gas, there is a force so powerful that entire star systems can be torn apart by it in silence. At the center of our galaxy lies a supermassive black hole known as Sagittarius A star. It contains the mass of millions of suns compressed into a region smaller than our solar system. From Earth, hidden behind dense curtains of interstellar dust, it appears calm and invisible. But deep near the galactic core, gravity becomes so extreme that even the oldest stellar partnerships can be destroyed in moments. Many stars in the universe are not alone. In fact, a large percentage of stars exist in binary systems, two stars orbiting one another in delicate gravitational balance. Some have danced together for billions of years, circling endlessly through space like cosmic companions bound by invisible threads. But near the center of the galaxy, those threads can snap. Imagine two stars traveling peacefully together through the crowded core of the Milky Way. Around them, thousands of stars drift through dense clusters, all orbiting the hidden black hole far away in the darkness. For millions of years, nothing changes. Their orbit remains stable. Their shared motion becomes almost eternal. Then, slowly, almost imperceptibly, gravity begins to pull them inward. The closer a binary system moves toward the galactic center, the stronger the tidal forces become. Gravity near a supermassive black hole does not pull evenly. One side of a system experiences a stronger pull than the other. Over time, this imbalance stretches the orbit between the two stars, like invisible hands pulling at opposite ends of a rope. Eventually, the system reaches a point where the gravitational difference becomes too powerful to resist, and then the pair breaks apart. One star may be captured into a new orbit around the black hole itself, trapped forever in the chaotic heart of the galaxy. The other may be hurled outward at unimaginable speed, launched across the Milky Way like a stone from a sling. These escaping stars are known as hypervelocity stars. Some travel fast enough to completely escape the gravitational pull of the Milky Way, racing into the darkness between galaxies at millions of kilometers per hour. What is astonishing is how quiet this process truly is. There is no sound in space, no cracking noise, no explosion that echoes across the stars. Ancient systems that survived for billions of years can simply unravel in silence beneath the pull of gravity. Astronomers believe some hypervelocity stars we observe today may have once belonged to binary pairs destroyed near Sagittarius A star. Their paths through space point backward toward the galactic center, like trails left behind by ancient catastrophes. Some of these stars move faster than 500 kilometers per second. At those speeds, a star could travel from Earth to the Moon in under 15 minutes. Yet even more fascinating is what remains behind. When one star is ejected, the companion often falls into a highly distorted orbit around the black hole. Near Sagittarius A star, astronomers have observed stars moving at extraordinary speeds, whipping around the invisible center in tight elliptical paths. These stars help scientists measure the black hole's mass and confirm its existence. One famous star, called S2, completes an orbit around Sagittarius A star in about 16 years. At its closest point, it moves thousands of kilometers per second through the galactic core, tracing the outline of something humanity cannot directly see. Watching those stars is like watching leaves spin around an unseen whirlpool. The closer scientists looked, the clearer the picture became. The center of the Milky Way is not calm at all. It is a region where gravity dominates everything, a place where orbits bend, time shifts subtly under relativity, and stellar systems can be broken apart forever. But black holes do not destroy only binary stars. Dense stellar clusters near the galactic core constantly interact gravitationally. Stars tug on one another, exchange momentum, and sometimes fling neighboring systems into chaos. Entire planetary systems may become unstable. Worlds could be stripped from their parent stars and cast adrift into interstellar darkness. Some rogue planets wandering through the galaxy today may have once orbited suns that ventured too close to the center. Even light struggles there. Surrounding Sagittarius A star is a turbulent environment filled with hot gas, magnetic fields, X-ray flares, and streams of accelerated particles. Occasionally, matter falling toward the black hole heats up intensely before disappearing beyond the event horizon, releasing bursts of radiation detectable across space. Yet despite all this violence, the black hole itself remains strangely quiet from a distance. If you looked toward the center of the galaxy with human eyes alone, you would not see destruction. You would only see a dense river of stars glowing softly behind dark clouds of dust. That is one of the strangest truths about the universe. The most powerful forces are often invisible. Gravity leaves no color in the sky, no visible rope connecting objects together. Yet it shapes galaxies, bends light, tears apart stellar systems, and controls the motion of nearly everything in existence. Even our own solar system drifts under its influence, orbiting quietly around the Milky Way's center once every 230 million years. Right now, as you rest beneath Earth's night sky, the galaxy continues its slow-motion dance. Somewhere deep near the core, stars are circling the black hole at impossible speeds. Some systems are forming, others are ending. Ancient partnerships between suns are being stretched apart in silence. A lone star may already be racing outward into intergalactic darkness, carrying with it the memory of a system that no longer exists. And far away from the crowded galactic center, here on a quiet planet orbiting an ordinary star, we remain suspended within that same immense gravitational story. The Milky Way is not still. It is alive with motion hidden beneath silence. And at its heart, unseen in the darkness, gravity continues its patient work. There are stars in the Milky Way that are no longer orbiting the galaxy. They are not slowly drifting away over billions of years. They are fleeing at such extreme speeds that gravity itself can no longer hold them. Right now, somewhere in the vast darkness beyond the spiral arms, a few lonely stars are racing outward at more than 500 kilometers per second, fast enough to escape the Milky Way forever. And once they leave, they will never come back. For most stars in the galaxy, gravity acts like an invisible anchor. Every star you see in the night sky is caught within the enormous gravitational embrace of the Milky Way. Our own sun, along with Earth and the rest of the solar system, is orbiting quietly around the galactic center at incredible speed. Yet despite that motion, we remain bound to the galaxy's immense dark matter halo. But not every star stays trapped. Occasionally, something violent happens. A star passes too close to the supermassive black hole called Sagittarius A star at the core of the Milky Way. Or a binary star system experiences a catastrophic gravitational interaction. In rare moments like these, gravity transforms from a gentle guide into a cosmic slingshot, and one star is thrown away. These runaway objects are known as hypervelocity stars. They move so fast that they exceed the escape velocity of the galaxy itself. Instead of continuing their orbit around the Milky Way, they break free entirely, launched into intergalactic space where almost no stars exist. The first confirmed hypervelocity star was discovered only in 2005. Before then, astronomers suspected such stars might exist, but seeing one was another matter entirely. When scientists measured its speed, they realized something astonishing. It was moving too fast to remain part of the galaxy. Since then, researchers have identified more of these stellar fugitives, each carrying clues about the invisible forces shaping the Milky Way. Some are young blue stars blazing brightly through space. Others are older and quieter, wandering outward alone through the darkness. Many of them appear to trace their origins back toward the galactic center. The process that creates them is both elegant and terrifying. Imagine two stars orbiting one another peacefully for millions or even billions of years. Together they drift too close to Sagittarius A star. As the pair approaches the black hole, the gravitational pull becomes uneven. One star falls slightly closer than the other. Then suddenly, the system breaks apart. One star is captured by the black hole's gravity. The other is hurled outward at unimaginable speed, accelerated like a stone released from a sling. In mere moments, an ancient stellar partnership is destroyed forever. The escaping star begins a journey that may last longer than human civilization itself. It crosses the spiral arms of the galaxy. It passes through clouds of gas and ancient stellar streams. Eventually, it reaches the thin outer halo where stars become rare and darkness dominates. and then it leaves. Beyond the Milky Way lies an almost incomprehensible emptiness. Galaxies are separated by millions of light years of mostly empty space. A hypervelocity star entering that darkness may travel for billions of years without ever passing near another galaxy. It becomes a solitary lighthouse drifting through the cosmic ocean. What makes these stars especially haunting is their loneliness. Most stars belong to systems, clusters, or galaxies. They travel surrounded by companions and structure. But hypervelocity stars abandon all of that. They become isolated wanderers carrying only the momentum of a violent past. Some may even carry planets with them. Astronomers believe it is possible that certain hypervelocity stars could retain distant planetary companions after ejection. If so, entire worlds might be racing through intergalactic darkness around a star that no longer belongs anywhere. Imagine standing on such a planet. There would be no bright Milky Way stretching across the sky, no crowded field of nearby stars. Over time, the home galaxy would shrink behind you into a distant, glowing spiral suspended in endless blackness. The night sky would become almost empty. Yet even as these stars escape, they continue teaching us about the galaxy they left behind. By measuring their speeds and trajectories, astronomers can study the gravitational structure of the Milky Way, including its invisible dark matter halo. The paths of hypervelocity stars help scientists estimate how mass is distributed throughout the galaxy. In a strange way, runaway stars map the prison they escaped from. Some researchers also suspect that not all hypervelocity stars come from black holes alone. Violent supernova explosions inside binary systems may eject companion stars outward at enormous speed. Dense stellar clusters can also create chaotic gravitational encounters capable of flinging stars away like sparks from a fire. The universe is filled with invisible mechanisms constantly reshaping motion. And yet, despite the violence involved, the departure itself is silent. There is no sound when a star escapes a galaxy. No thunder echoes through the spiral arms. No cosmic alarm announces its departure. Somewhere in the darkness, gravity simply changes a trajectory and a star begins falling outward forever. The Milky Way itself may have lost countless stars this way over billions of years. Some are already unimaginably far away by now, drifting between galaxies where almost nothing shines. Perhaps one day, far in the future, our own galaxy will appear only as a faint patch of light behind them. Still, there is something strangely beautiful about hypervelocity stars. They remind us that galaxies are not fixed islands. They leak matter into the cosmos. Stars can be exchanged, stolen, captured, or thrown away. Even enormous structures like the Milky Way are not permanent containers. They are dynamic systems constantly changing over time. And somewhere tonight, beyond the familiar glow of the galactic plane, one of these runaway stars continues its endless journey. Alone, silent, unstoppable. A tiny point of light escaping the galaxy that once called it home. Long before Earth had oceans, before the first cell existed, before even the sun was born, tiny grains of dust were already drifting through the darkness of the Milky Way. At first glance, cosmic dust sounds unimportant, just microscopic particles floating silently between the stars, something cold, lifeless, empty. But the deeper scientists look into these drifting clouds, the stranger the truth becomes. Because hidden inside some of that dust are organic molecules, complex carbon-based compounds that may have helped prepare the universe for life itself. In other words, the story of life on Earth may not have begun on Earth at all. It may have begun in the dark spaces between stars. The Milky Way is filled with enormous clouds of gas and dust, known as interstellar nebulae. Some stretch across hundreds of light years, faintly glowing under distant starlight. Others remain almost completely invisible, hidden in cold regions where temperatures drop far below freezing. Inside those clouds, chemistry never stops. Atoms collide slowly over millions of years. Radiation from nearby stars energizes frozen particles. Tiny dust grains become surfaces where molecules can form and combine. In these quiet environments, some surprisingly complicated compounds begin to appear. Astronomers have detected alcohols, simple sugars, carbon chains, and molecules known as polycyclic aromatic hydrocarbons drifting through interstellar space. These substances are not alive, but they are among the chemical ingredients associated with biology. The universe, it seems, naturally creates the raw materials of life. That realization changed how scientists think about our existence. For a long time, humanity imagined life as something isolated and fragile, perhaps unique to Earth. But modern astronomy suggests that the chemistry leading toward life may be happening all across the galaxy. Everywhere stars are born, the ingredients may already be waiting. Some of these molecules form in the atmospheres of dying stars. When large stars approach the end of their lives, they begin shedding enormous amounts of material into space. Carbon, oxygen, silicon, and heavier elements forged deep within stellar cores are released into the galaxy like cosmic ash. Over time, that material cools and condenses into microscopic grains of dust. Those grains drift through interstellar clouds for millions of years. Eventually, they become part of new stars, new planets, new worlds. The atoms inside your body may once have belonged to ancient dust floating between forgotten stars long before the sun existed. And perhaps even more astonishing is this: some of that dust may have reached the early Earth directly. Scientists studying meteorites have discovered organic molecules preserved inside them, compounds that formed in space before our planet was fully developed. Comets and asteroids bombarded the young Earth constantly during its early history, delivering water, minerals, and carbon-rich material from the outer solar system. Some researchers believe these impacts may have helped seed Earth with the ingredients necessary for life to emerge. If that idea is true, then life on Earth was shaped not only by oceans and geology, but by chemistry born in interstellar darkness. In a sense, the galaxy itself participated in our creation. This possibility becomes even more fascinating inside giant molecular clouds, the cold stellar nurseries where new solar systems form. These immense clouds already contain rich mixtures of organic material before planets even exist. As stars ignite within them, surrounding disks of gas and dust begin clumping into asteroids, moons, and planets. Whatever chemistry exists inside the cloud becomes part of the worlds that emerge from it. Every newborn solar system inherits the memory of ancient stars. That means the ingredients for life may not be rare accidents. They may simply be part of the natural cycle of galactic evolution. Stars form, stars die. Dust spreads outward. New systems rise from the remains. And within that endless cycle, chemistry slowly grows more complex. The Milky Way may be filled with countless worlds carrying similar ingredients, hidden beneath oceans, frozen inside comets, or buried beneath alien skies. We still do not know how often life truly appears. That mystery remains unsolved. But what scientists increasingly understand is that the universe seems surprisingly willing to create the conditions life requires. Even in places that appear cold and empty, complexity quietly emerges. And perhaps that is one of the most beautiful truths hidden inside astronomy. The universe is not sterile. It is creative. Even dust participates in the story. When we look at the night sky, we usually focus on stars because they shine brightly. But the dust between them matters just as much. Without dust, planets could not form. Water could not gather. Organic chemistry would struggle to develop. Dust is where structure begins. It softens harsh radiation, cools collapsing clouds, and helps matter clump together. Entire solar systems are built from these tiny, drifting grains. The earth beneath your feet was once dust. The iron in your blood was once forged inside exploding stars. The carbon in your cells may once have floated silently through interstellar space long before the dinosaurs, before Earth's oceans, before the sun itself existed. And somewhere tonight, beyond the visible stars, enormous clouds of cosmic dust continue drifting through the galaxy. Inside them, chemistry is unfolding slowly in the cold dark. New stars are beginning to form. Future planets are gathering shape. Tiny organic compounds are assembling molecule by molecule on frozen grains suspended in silence. Perhaps somewhere far away, another world is already forming from that material. A world where oceans will eventually appear, where skies may someday glow above strange continents, where living things might one day look upward into their own night sky and wonder where they came from. And the answer, just like ours, may begin with dust. Not ordinary dust, but ancient stardust carrying the quiet potential for life across the galaxy. Before Earth had oceans, before mountains rose from the surface of the planet, before the moon circled the sky, the atoms inside your body were already beginning their journey. The iron flowing through your blood, the oxygen in your lungs, the calcium inside your bones, and the carbon woven through every living cell were not created on Earth. They were forged deep inside ancient stars that lived and died billions of years ago, long before our solar system even existed. In a very real sense, you are not separate from the galaxy, you are part of it. For most of human history, the night sky seemed distant. The stars looked unreachable, cold, and completely disconnected from everyday life. Ancient civilizations gazed upward and imagined gods, spirits, or mysterious fires burning beyond the world. But modern astronomy revealed something even more beautiful. The universe is not separate from us. It flows through us. Every star shining in the Milky Way is part of the same cosmic story that eventually led to Earth, to oceans, to life, and to you sitting here now beneath the night sky. In the beginning of the universe, almost nothing existed except hydrogen and helium. These were the first simple elements born after the Big Bang. There was no iron, no oxygen, no carbon, no calcium. None of the materials needed for planets or living things had formed yet. The early cosmos was simple and dark. Then the first stars appeared. Deep within their cores, gravity compressed hydrogen atoms together until nuclear fusion ignited. Stars became enormous furnaces, transforming simple elements into heavier ones. Over millions of years, stars created carbon, oxygen, neon, silicon, and eventually iron. But iron marked a limit. Once massive stars filled their cores with iron, they could no longer sustain themselves. Gravity overwhelmed them. Their cores collapsed in fractions of a second, and the stars exploded as supernovae, scattering newly forged elements across space. Those explosions seeded the galaxy with the raw material for future worlds. Every atom heavier than hydrogen carries the memory of ancient stars. The calcium in your teeth was born in stellar fire. The oxygen you breathe was created in the hearts of massive suns. Even the gold humans treasure may have formed during catastrophic neutron star collisions, where some of the most violent forces in the universe forged heavy elements before casting them outward into the galaxy. We are surrounded by the remains of dead stars, and somehow from those remains, life emerged. Over billions of years, clouds of enriched gas and dust drifted through the Milky Way. Gravity slowly gathered portions of that material together, forming new stars and planetary systems. One of those clouds eventually became our solar system. At its center, the sun ignited. Around it, planets formed from leftover dust and rock. On one small world orbiting quietly in the outer spiral arm of the galaxy, chemistry slowly became biology. And eventually, consciousness appeared. The universe became able to observe itself. That idea can feel almost impossible to fully grasp. Every thought you have is carried by matter that once existed inside exploding stars. Every heartbeat is powered by atoms older than Earth itself. The Milky Way is not merely above you, it is within you. Right now, as you rest beneath the night sky, your planet is moving through space at extraordinary speed. Earth orbits the Sun at roughly 30 kilometers per second. Meanwhile, the Sun carries the entire solar system around the center of the Milky Way at over 200 kilometers per second. And the galaxy itself drifts through the larger universe beyond. Yet despite all this motion, we rarely notice it. We feel still. But we are travelers moving through a cosmic ocean. Sometimes it is easy to feel small beneath the scale of the universe. The Milky Way alone contains hundreds of billions of stars. Beyond it lie trillions of other galaxies stretching farther into darkness than the human mind can comfortably imagine. And yet, within that immensity, something extraordinary happened. Matter became alive. Stars created the elements necessary for biology. Planets formed from stellar debris, and eventually, living beings began asking questions about where they came from. That is part of the galaxy's story too. The universe is not only stars and black holes and empty space. It is also memory, awareness, curiosity, and wonder, emerging from the very matter stars once forged. Somewhere tonight, new suns are forming inside cold clouds of dust. Somewhere, ancient stars are collapsing into white dwarfs or neutron stars. Somewhere, rogue planets drift silently between the spiral arms. Somewhere, gravity continues shaping galaxies in darkness. And here on Earth, a conscious mind is listening to the quiet story of the cosmos before sleep. You are connected to all of it. Not metaphorically, physically. The atoms inside you once traveled through interstellar clouds. They survived stellar explosions, crossed light years of space, became part of forming planets, oceans, mountains, trees, and eventually living creatures. You are the continuation of a journey billions of years old. And perhaps that is why the night sky feels strangely familiar to us. Because on the deepest level, it is home. The Milky Way is not just a distant spiral stretching across the darkness. It is the environment that shaped every atom we possess. Its stars created the chemistry of life. Its gravity carried our solar system across cosmic time. Its ancient explosions made our existence possible. Tonight, while the galaxy turns silently overhead, you remain part of that motion, a small warmth beneath ancient stars, a living fragment of cosmic history resting briefly within the spiral arms of the Milky Way. And if you are still awake all the way to the end of this journey, thank you for drifting through the galaxy with me tonight. I hope you sleep deeply and dream softly of the stars.